minutes and 2 minutes for questions. So it's a little bit of tight.
Okay. Can everyone see my screen?
Yes.
Perfect. Okay. I think Anne is taking the. Oh, sorry, I'm on the wrong page.
Yeah.
Okay.
Yeah.
Just let me know when you want to advance.
So hi everyone. We're the microplasticators, and we've been working on a detection solution for the microplastics issue. Next slide, please. So essentially, we looked into the microplastics problem and what it encompasses and did the by the numbers for the same. Now, microplastics are essentially particles that are less than 5 millimeters in size, and we looked at the current solutions for the same. Neem, could you move to the next slide? Yeah. So we looked at research that has been done around microplastics, and even though we know that microplastics are present a lot and ubiquitous in the environment, the effects that they have on the human and the environmental health is not completely understood. And all the mechanisms that are present for their detection right now are very expensive or time consuming. They're listed on slides. So what we wanted to do was develop a low-cost, scalable, open source solution to this. And we looked at detection using impedance spectroscopy for the same. But before we get into the solution, we want to talk about how big this problem is. And for the same, yeah. So according to one 2015 some study, there's apparently 80 million tons of plastic that enters the ocean every year, and only 1% of it is found in the surface. That leaves, if you do the calculations, a rough estimate of around 649.8 million tons of microplastics in the oceans. You can also see some figures of rough estimates of how much plastics is present in what we consume on a day-to-day basis. And this is why, and the number sort of increases as the sensitivity of the instruments that we have increases. And so detection becomes a really crucial step in the process. And yeah, Ravi, take it.
Yeah, next slide, please. So we'll just describe, or I'll describe just the how this impedance spectroscopy works and what is the solution that's been published. This is a paper that Manu pointed out to us. So it's basically just telling you what's in the paper. So what they do is, what is impedance? Basically, it's the generalization of Ohm's law. If you put a capacitance or an inductance in the circuit, then the voltage and the current are now out of phase. And by measuring the change in the phase, you can measure properties of material. So if you introduce a plastic into a capacitor, it can change the capacitance of the instrument. Or if you put an iron particle inside a coil, you can change the inductance. So that's the idea, basic idea. Next slide, please. So here's the setup that was used by the team that published. They're using a flow-based method, and it's not clear to me because flow adds another complication here, but the key idea is it flows through a cell, which is like a capacitor, and the particles distort the capacitor or change the capacitance, and that's detected using a lock-in amplifier. Next, and the signal can be at various frequencies, and I'll just explain briefly. Yeah. So what they used is they used a set of plastic beads of different sizes, and then used comparable biological things of the same size, like brine shrimp egg, seeds of various kind, teff, various things. So basically, they want to show that they can also distinguish between plastics and biological material. Next slide, please. So here's the key component here, the lock-in amplifier. How does it work? It's a very simple idea. So you take the product of the input signal and the signal that comes after it passes through the capacitor. So you introduce a phase shift, and it uses a very simple trigonometric relationship. It's if you multiply two cosines, cosine A and cosine B, it can be decomposed as cosine of A plus B and cosine of A minus B. And now if the two frequencies are close, if A and B are only separated by a phase angle phi, then you get two components, one which is twice the frequency and another which is only the phase angle. So, and then if you apply a low pass filter, you remove anything that has a frequency component and you end up reading purely the phase change. And this becomes very, very sensitive because even with a very noisy signal, you can extract this phase change and you can actually, and apparently can go down to 1 part in a million sensitivity. Next slide, please. So here's how it looks. So what they claim, so just to quickly summarize what's in here, the key claim they're making is at both 1.1 megahertz and 10 kilohertz, the phase change is negative for biological samples and positive for plastics. So that's a key takeaway message here. Next slide, please. Yeah, go ahead.
Okay. Can you hear me?
Yeah.
Oh, you can.
Yeah.
Okay, good. So we need a couple of things to do this for our prototype. We want to make it as low cost and simple as possible. So we need a signal generator. So we can use a 555 signal generator, which is just like a little chip that's maybe 50 cents. It's really cheap. So we could try one of those, or use a tone generator and a headphone jack, which I'll explain more about in a minute. Then we need a capacitor. So in the paper that we just talked about, they used copper PCB plates as the capacitor. I couldn't actually get my hands on those, so we just used tin foil instead, or aluminium foil. And then for the detection, we need to use an oscilloscope. So then for our initial test, we wanted to test kind of air, so with nothing in it, tap water and microplastics, brine shrimp, eggs. And then we wanted to try it out on milk to look and see if we could detect microplastics in milk, because that's something that, you know, is consumed widely. Also a sample that we could kind of all access from all our different parts where we're around the world where we're living, that we could all test. So we were like thinking that milk might be a good idea, and also maybe to look for microbes in milk, to look at milk spoilage potentially as an idea. And then at the end, we wanted to simplify our idea, miniaturize it, and kind of make it scalable. Then, so we came up with the idea of, Ravi was looking at the idea of looking at using your laptop as an oscilloscope. So he found a video that kind of shows you how to do that. And I was looking at using the laptop as the tone generator, as the signal generator. So you can do that by playing different tones of different frequencies, and then using a headphone jack, splitting out the cables from that and taking those frequencies and putting it into the oscilloscope. And then for detection, we ended up using an oscilloscope that we have in the lab. So we could look at the signal we put in, and then the signal that comes out after passing through our sample, and look at the kind of the waveform of both. So our first step was to use the tone generator. So there's the headphone jack attached into the oscilloscope. So we kind of soldered wires onto the headphone jack to the ground and the positive pin there. And you can see when you change the frequency, we can see a change in the oscilloscope. We also tried generating signals with a red Pataya board and the 555 module. Couldn't get the red Pataya board working, but the 555 module gave us nice square waves. So there's a potential to turn those square waves into sine waves later on if we want to. Then we add our Frugal capacitor. So this is just tin foil on 2 acrylic plates. And we measure the voltage across the headphone jack, the positive and negative of the headphone jack. And then we also have a channel into the oscilloscope across the second resistor there after the tin foil. We played with resistors, adding different resistors to see what the effect on the waveforms were. And we saw we could kind of decrease some of the noise. But really, if we want to get rid of those noisy signals, we need the low pass filter on the lock-in amplifier. Then we tried measuring phase changes at multiple frequencies. We found we got, with no sample there, we got a roughly 2-fold change for a 2-fold change in frequency. But what we said was we needed a higher capacitance. So we needed to basically bring those plates closer together to get better readings. So our little tube there, we needed to replace that with a smaller cuvette. So we got a smaller cuvette to move the plates closer together, and we tested it with air, water, and microplastics. We didn't get a chance to do brine shrimp eggs or milk, but we saw a phase change of 0 degrees for all samples when we worked it out. But we think what this is that our capacitor needs to be smaller or larger relative to the size of the cuvette, so that it's kind of the cuvette and the water or your sample is taking up all of the space. I'll pass over to Ravi.
So next slide, please. So we just want to quickly, okay, so here's another by the numbers. So we actually did some rough calculations of what happens if you, how much effect. So the dielectric constant of water is 80. The bead is 2. So basically putting beads in is reducing the capacitance. And we can estimate that having one bead at a size of 2 millimeter cube, let's say, would be about 1,000. Oh, yeah, 1,000. So we can detect these capacitive changes if you had a lock-in amplifier, or if you had more beads. So one of the two, and so it is detectable, at least roughly, by playing with these numbers. Next slide, please. So the idea is that we can eventually, maybe if we can distinguish live bacteria from plastics and things like that, then you can actually use it even for looking at cultures and looking at numbers of bacteria. So you can look at milk and beer things. So the key things to be done are like use the 555 based amplifier, so oscillator, so it can be a miniature generator, set up the lock-in amplifier, deal with the capacitance to package it nicely, and then just tune the resistors and frequencies to see which one works best, and then that's it. That's our idea of how we're going to go forward.
So that was fantastic, team. You guys set a pretty high bar for everybody. I don't know if we have time for questions. One question, just a side comment. I think the capacitor really has to be small.
Yeah.
Because what you want to do is the ratio of your volume
Yeah.
of the capacitor to the plastic volume is what you want to bring down.
Yeah.
And there's also this thing called fringe fields. When the two capacitors come, there are fields on the sideline which are not seeing the volume that you care about. So,
right.
But we'll talk offline.
Yeah.
I mean, I have to say, I am thrilled since the last chat. This is,
Thanks.
it's got real legs. But any questions anybody has? Yes, Tanvi.
Are there frugal versions of the oscilloscope? Like,
Yeah.
That's so the laptop. So the oscilloscope is only for matter of testing in the beginning, because eventually the lock-in amplifier will give you a readouts, which is just basically reading out the phase change. And actually, if you look at like how reagents are supplied, for example, if you look, Illumina will send you something, they have a small detector that actually records the temperature every 5 minutes. It's like a really small thing. So we could have something like that, which will record the phase changes as we add, and then you can then download it to a laptop or something later on, or a phone, and get the numbers.
I think eventually you don't need an oscilloscope. That's
Yeah,
just a debugging tool.
Yeah. But that can be done
The math
cheap.
of this is so simple that couple of cents of electronics is all you need to actually implement. I think the lock-in amplifier is the tricky part.
Yeah, I looked up. You can do it.
There are a couple of tricks to implementing something like that. But you know, analog electronics, it really scales.
Yeah. And there's a chip that Texas Instrument makes. I looked it up. You can get it, and it's only like 50 cents again. So it's really cheap to put this together.
Yeah. Okay, to be continued. We're gonna switch to the Shisto team. Also, if the teams want have names, you can declare your names there. I saw the Shisto team had a pretty cute logo on the board inside. I only later on figured out what that was drawn. If you want to draw that, it is actually okay.
Who starts? All right. Just pass the mic around so that people on Zoom can hear me.
All right.
Okay.
Can people hear me? Hopefully. Okay, yeah, so we're the SchistoFlow team, and we're going to talk to you guys today about our project, which we've called Adaptation of Planktoscope as a low-cost diagnostic for schistosomiasis infection in urine. So just a little bit background on what schisto is. It's a neglected tropical disease and the second most prevalent parasitic disease after malaria. And it's responsible for around 24,000 deaths every year and 2.5 million disability adjusted life years lost. And around 236 million people across the world require mass drug administration to kind of help deal with the disease. And if you look at the kind of distribution of where people are getting schisto, it's mostly located in sub-Saharan Africa and Brazil and other tropical regions. And the WHO basically identified it as a neglected tropical disease on their roadmap for 2021 to 2030. You can go to the next slide. And specifically, they, in order to address the challenges with schisto, they called for development of standardized, sensitive, and point-of-care diagnostics for different prevalence settings and all schistosome species. And so we chose to focus in on urogenital schistosomiasis, and the current gold standard for detection of this type of schisto is urine filtration microscopy. And basically that works by putting urine through a filter and then which will catch all of the eggs and then imaging those eggs on a microscope. And it costs around $1 to $2 per diagnosis because of the filter. And the sensitivity for it is extremely low at around 53.8. And so we wondered, can we use the planktoscope to create a new diagnostic that can avoid the filtration step and also increase the sensitivity of detection of schisto.
So to do this, we had access to fixed schistosomiasis eggs that we suspended in either water as a proof of concept or urine and then imaged. And we first wanted to try out the current workflow with the planktoscope, which is imaging through the planktoscope through images and then segmenting on a software called EcoTaxa that I'll talk to in a bit. And then after that, we identified some things that could be optimized. The current workflow is here at the bottom, and then what we tried to optimize is here at the top. So first we tried to image with what is currently done. So we put schistosomiasis in different concentrations in urine and imaged 10 mL of urine, which is the current volume used for diagnostics. And we wanted to be able to test a wide range because there is a threshold for how many eggs are in 10 mL of urine that make it either a heavy or a light infection. So we basically passed all these different concentrations through the planktoscope, took images, and then the planktoscope automatically segments the images, which means that it grabs all the liquid that went through and all the images taken and breaks them up into tiny little objects identified that you can see here on the left. So the 4 bottom ones are schistosomiasis eggs, but then it collects a bunch of dust and other particles that could be contaminating. And then what we had to do was to train this model called EcoTaxa that's widely used to identify species in oceanography and other things to be able to identify this new species. And that was done by manually validating what looked like a schisto egg, which are all these little green boxes here. And then we trained it on more of our photos to see if it could correctly identify that versus all the other particles that could be in urine. And here, compared to what we had manually labeled on the left in green, it could, with accuracy of like 63 to 97%, detect schistosomiasis in these boxes in blue in blurry conditions, like high light conditions, low light conditions, which we wanted to optimize for depending on what the collection situation was. However, we did identify that this took a long time, mainly because the segmentation of the planktoscope takes a really long time. So for 10 mL of urine, it took approximately like 2 to 3 hours to break up all the photos we took into the little objects. So we thought that maybe if we trained our own segmenter and then classifier, it could perform much faster and reduce the time of diagnosis. And we tried to do this through 2 main things, which was collecting videos instead of images, since the like start and stop of flowing and taking images takes a long time, and then also training a new segmenter that takes less time than the planktoscope.
Okay, yeah. So as Janella mentioned, now we wanted to talk more about the image and video acquisition we did for the computational side, which was trying to decrease the time for diagnosis. So the first thing that we did is we imaged eggs via the squid microscope at different magnifications and then also different focus and light conditions. basically to form the basis for our training data set for our model, and to be able to classify eggs that are taken at a variety of different image conditions. And then before we started with the taking the videos on the planktoscope, we wanted to also optimize certain parameters such as flow rate and capillary size. And so with the flow rate that we optimized for, which is 1 ml per minute, we were able to take a whole sample in 10 minutes. And then also have like still a good image condition. Also with capillary size, being able to have the whole field of view of the sample. Yeah. Okay, and then from there, we modified the planktoscope to be able to take a video of our sample. So here's just an example on the left. And then the 2 photos are taken from videos that we took. Oh, so the middle picture is fresh urine with no eggs. So that's kind of the null sample for our training set. And then on the right, you can see the test data set, which is fresh urine dosed with those same concentrations of eggs.
Am I audible?
Go ahead, Beba.
All right. Yeah, so after that, we uploaded the images and videos on RoboFlow and created a data set by manually labeling the eggs. And then we used YOLO, which is an open source image-based machine learning library. And we used 2 models for it and trained the model for around 20 minutes. And then we could see significant progress and better results over increasing the training time. And can we move on to the next slide? So this was the performance of the model on the training images. And can we go to the next? Yeah, so this was the model that we used, and since we didn't have many samples which had both the impurities and the eggs together, this was our first sample with both an impurity and an egg, and we can see a clear difference between the confidence level between the egg and the impurity. And this performance was received on training it for 40 epochs. And after that, we had finally trained it using RoboFlow, which is a paid platform for training. And we could see after 200 or 250 epochs, the metrics are getting much better and more precise. The both all of the mean precision and recall.
So after trying these 2 methods, we did identify that planktoscope could be feasible to collect images, and we modified it to take videos to diagnose schistoinfection. Sorry. However, we identified that the current workflow could take a very long time to segment. So even though the classification, like performance metrics between Ecotaxa and YOLO are comparable at this point, more optimization is needed with YOLO, but YOLO would be preferred in the future due to lower time of diagnostic. So as for further work, we actually classified it on a very specific species of schistosomiasis that's present in intestinal schistosomiasis, but we want to train this on the specific species that happens in urogenital schistosomiasis, which actually looks like this, but we trained it on what looks like this here on the left. So that would be the first immediate step. And then a big cost and also time constraint of the planktoscope is that there's a pump that moves the liquid through the tube. But if we could investigate a gravity flow driven mechanism to remove the pump from the design and reduce the cost, that would be also very beneficial. And lastly, we could increase the speed of classification using a neural compute stick that would allow the segmentation and classification of our algorithm directly on the planktoscope as it's acquiring. And after all this, the final step would be to conduct sensitivity and specificity tests on actual clinical urine samples, since we tried our best to replicate what a urine sample with eggs would look like, but there could maybe be some other things in there. Thank you.
That was fantastic.
Thank you.
I mean, I don't know if everybody in the class realized the data set that they showed is actually on human urine. So this is pretty close to as it gets. The only caveat
Oh,
is that
I can see
the egg is the intestinal egg as compared to the
other
very
things that could appear as eggs.
any questions?
I think
Yeah, go ahead.
yeah, there's a few on Zoom. I'll choose one. Ravi asked, are there any other things that could appear like eggs. And yeah, that's a great point. That's something that we wanted to look into when we imaged the real urine. And the main thing, we also looked into other diseases that could make it look like eggs in urine. And there aren't that many that appear in urine, but the main thing are called urine casts, which are like debris from calcified urine pieces that clump together and they look like a little clump, like this impurity. That's basically a urine cast, we believe. So I think that's the main other thing that could appear like an egg, since there's not other parasitic diseases that we saw that appear in urine.
Yeah, I mean, I think one thread that's very valuable is that Shishto has this little horn that nobody really understands why it has this horn. But it's like a little unicorn horn. That's the telltale sign. So when we train people,
Yeah.
that's what we look for right there.
Yeah.
And even if the object, and I think this is why I love the flow-through system, the object is actually tumbling in flow. So if the horn was not visible in one image, technically it should be visible as it's going by.
Yeah. Yeah, and that's why we think that taking video instead of photos will be really, really useful.
And the comment on the segmenter, we know that for a long while. It's just, there's no reason to segment on the unit itself. And also this is where the compute stick comes in.
Yes, for sure.
Okay, to be continued. This was awesome.
Thank you.
You will either you or a team member join Zoom and share your screen. I can join this thing. Okay, great. For everyone, if you're going to present off of your laptop, if you could just join the class meeting so that you could share your screen when it's your turn, that would be great.
Oh, that's actually good.
Yeah.
Oh, sorry.
I don't know. It's good. Now.
Just turn off the audio from my computer?
Yeah, your computer can just be like, you can literally leave audio from Zoom.
Okay, okay, okay.
Yeah, and just use the
Great.
screen.
That's a good one.
Yeah, very good.
Okay, amazing. Can everyone hear me?
It's funny, you guys have scheduled it in a way, there's a theme.
There is a theme.
The first three are all on detection.
Yeah. So we're talking about a different kind of remote monitoring device for something a little larger. And in our device, we were essentially looking at the idea of monitoring invasive crayfish and kind of thinking about a remote monitoring device that can help monitor free-swimming aquatic invasive species. And this is our team. It's been really wonderful to work with everyone and learn from their different areas of expertise. And yeah, she was going to start with why we became interested in this problem in the first place.
Yep. The motivation of our project is let's farm crayfish, one of the major invasive species in my home country, Japan. And historically, they introduced by US into 1927, and now competing with the native crayfish species and other species. And since they have high adaptability and reproducibility, now they are found everywhere in Japan and now classified as a designated invasive alien species in Japan. And this invasive crayfish has a significant negative impact in multiple perspectives. And from ecological point of view, they cause the habitat change by damaging the underwater plant, which is important for other aquatic species, and it consequently affecting the economy such as fishery and agriculture. And not only they are destroying the habitat, but they're also carrying the pathogen that's so harmful to other aquatic species. And due to their nationwide spread, ironically, now most people in Japan enjoy crayfish fishing during their childhood.
Hello, am I audible?
Yes. Yeah, you're audible.
Yeah. So let's talk about who is the red fish or Clappy. So it is native to the southern United States and northeastern part of Mexico. And it aggressively outcompetes the native crayfish made for food or habitat. It has burrowing like behavior. And it's also comparatively larger in size and reproduces faster than most of the native species, giving it all the necessary requirements to be an invasive species. The next slide. Yeah, so as you can see in the picture, this is an invasive history of the red swamp crayfish. So it has been like the dark gray area is where it's been native to, and the red spots you see across the map is where it has been introduced as invasive species, and thus the spread began. It's now a cosmopolitan kind of presence, and for most reasons, it's for its economic value, it has been introduced in almost every continent. Yeah.
All right, now we will look into the existing monitoring methodologies. There are several ways which can be used to detect the crayfish nowadays. For example, it can be tracking, it can be direct observation, as well as it can be through environmental DNA or eDNA. However, there are problems associated with each of these methods. For example, when it comes to tracking and observation, it is number one, extremely time consuming, as well as it is very labor intensive. Likewise, when we will talk about environmental DNA or eDNA, one of the major problems is it is expensive. And since we need to collect the sample and send it and then wait for the analysis, therefore, at times it takes a lot of time to get the results. So we want to frugalize the whole process. Yes.
So essentially, we decided that we wanted to monitor sort of frugal remote monitoring device that can provide a notification system to preserve managers, especially biological preserves, for sort of low cost and low density crayfish detection. So when crayfish just begin to arrive in an ecosystem, can you manage to detect them before they actually become a problem? And we decided basically if we're detecting crayfish early, we want to target when they're smaller and less likely to be seen and less of a problem. And so we decided to target the juvenile part of the crayfish life cycle when they are also free swimming. And the juvenile crayfish are essentially miniaturized versions of adult crayfish, and they're pretty small. They're about 1 millimeter big. And based on this, we kind of came up with a set of design specifications we wanted our device to follow. It has to be able to effectively monitor high throughput area where a lot of water and a lot of biological material is passing through, which also means they can monitor plankton-like organisms. These aren't exactly a planktonic stage, but they are free swimming like plankton. It has to be able to identify juvenile crayfish, which are pretty small. They're about 1 millimeter big. And necessarily, since it's an aquatic invasive species, it has to be waterproof and require minimal maintenance. And this is the juvenile crayfish. So based on this, we kind of came up with a two-part system of sampling and detection. We decided to kind of build on the anglerfish model to create an anglerfish-like frugal underwater camera setup that essentially is an underwater camera trap that images a habitat. And we created sort of two prototypes of this, one over here, one in Germany with Chuzo. And then we developed an ML model that can basically identify red swamp crayfish observed in images. And this is also something we began to prototype. Yeah. And we, Shuza and I also went out and did some field work to kind of look at the habitats where crayfish are found and understand what are kind of some of the monitoring challenges that might arise. So I went to Jasper Ridge just down the road and took some videos inside streams to kind of understand what would it take to create a tool that would be useful to preserve managers at Jasper Ridge for monitoring crayfish. And Shuzo. Yeah.
So, and we also conducted field work in urban river areas in Dresden, Germany, where invasive crayfish is present. And to design the low-cost sampling device, we developed a prototype which composed of Raspberry Pi and camera and transparent waterproof box. And briefly, we put the Raspberry Pi and camera and battery inside a transparent box, and we put them in the water for the recording. And here's an example image taken from our low-cost devices. We successfully captured the interior liver. And however, so far we are not able to find any aquatic species during recording, so the detection is future work. And for the detection part, we aim to develop the machine learning model to classify the juvenile crayfish. And as a first step, we focused on the binary classification problem to distinguish the crayfish-like species from other species. And since the data set specifically designed for juvenile crayfish is not available, so we focus on the data set of the freshwater macroinvertebrates, which is publicly available. we select two different species, which one is a crayfish-like and the other one is not. And we build a simple ML model, which has 3 layers. And the first layer is the input with image, and output is 2 levels. And although it is quite simple, but model successfully distinguish the crayfish-like species with others with 100 accuracy.
ആർട്ടിഫിഷ്യൽ സെറ്റിംഗിൽ അത് ചെയ്തു നോക്കുക.
Oh.
Just give him a second.
Yeah, no problem. And yeah, sample image will be shown.
Yeah, go ahead, you can continue.
Yeah, Shujo, go ahead.
Okay, and we have some sample image. So just prefishing, yeah, like this. Yes.
Yeah. And based on our field work, we also realized this pipeline wasn't complete. It's a high throughput environment, which means there's a lot of water to sample in order to actually detect any crayfish. We went out several times to these rivers and didn't see not even a crayfish, not even a single fish. So there's some kind of filtration or concentration device that you need to maximize the likelihood you're actually going to find something, anything. And so we kind of started designing a filtration setup that can concentrate macroinvertebrate and macrovertebrate populations in these rivers. It's a really, really basic design that's essentially modeled off a crayfish trap, but the idea is the trap can be opened periodically to release everything that's in there before it's imaged. So essentially, it's maximizing the likelihood that you will detect something that you actually want to see. And we haven't got a chance to build it yet, but we began imagining what it might look like and what it might need. In terms of next steps, there's a lot to be done, and we're excited to continue this work. We need to kind of think a little bit more about what does it mean where you sample, also make this device a little smaller and lower cost. It currently costs about $100. We need to improve our ML model, obviously, for more complex classification tasks. It's difficult to access juvenile crayfish imagery. A lot of it is confidential and researchers don't share it. So we're trying to get access to that and improve the object segmentation, as the earlier team also discussed, and finally build a pipeline that connects the images we sample from our device to the ML model that we've created. And finally, like thinking a little bit more about the filtration device and what it actually might look like and testing it, because that's still a very open question, but it's just something we think might be important going forward. And yeah, very grateful to everyone who supported us in this project. And thank you. And yeah. Questions?
What was the illumination? I think I'm surprised. Maybe that was done in the day, because one of the challenges of underwater imaging is getting the light.
Yeah.
That's why anglerfish has this dangling light sometimes. So those 2 videos, that was just ambient illumination.
That is ambient illumination, yeah. And our imaging was honestly pretty good, especially in Shuzo's locations. In Jasper Ridge, where it's a little bit more turbid, it was a little bit more difficult. I think
that would be
it
variation.
Yeah, it would be a variation that exists. I think it's also important because crayfish are pretty crepuscular animals. Juvenile crayfish tend to be active more throughout the day. Adult crayfish are more crepuscular, but maximizing the likelihood might also mean more crepuscular work. So I think illumination is another part that could pretty easily be added, I think, into the box that we're currently doing. Yeah, but these are we're thinking of shallow, fast flowing rivers right now. So it hopefully makes our goal a little bit easier.
Yeah, no, I mean, I think in terms of thinking about the volume, it's fantastic to just have something incorporated in the system itself.
Yeah.
You are orders of magnitude large. For macro stuff, it does make a lot of sense.
Yeah.
Your depth of focus
Yeah.
can be large.
Yeah.
And, one of the threads is that it pushes in the direction of monitoring in general if crayfish is only one target. You would see a lot of other good
Yeah.
stuff.
Yeah.
System like this to quantify
Yeah. Yeah.
Yeah.
I mean, places like Jasper is so easily applied to like steelhead trout and stuff like that. Like these large animals that people are kind of looking for, but are having a lot of difficulty finding and that are important to figure out. And I think the idea is that this could be a device that could be sort of extended towards any kind of aquatic invasive species that's above a certain size threshold.
That is actually valid.
Yeah.
Because there might be some low-hanging fruits
Yeah.
while you develop something to get to hitting the crate.
Yeah.
You will see a lot of things eventually.
Yeah.
Okay, let's switch. Okay, the next.
Okay, so hello everyone. Our team, we have Elizabeth, Ben, and Ru. We have also Diego and Vibehub that are online, and myself, Ivana. And we've been working towards designing a low-cost ostomy bag. So a bit of context, there are 15 million people worldwide living with ostomy bags. It's this surgery that is performed when there's a colon cancer, Crohn, colitis, that consists on cutting the intestine, diverting it through the abdominal wall, and then all the stools go out from this little bit of intestine, and people need to use a bag to collect all of those stools. So the bags look like this. This design actually doesn't work very well, and it's actually very costly, especially in specific countries such as in India, where it costs $3 per bag. People sometimes need to use one per day or one every 2 days. So basically they cannot afford it a lot of times. So we interviewed a few people from India, and we want to you to hear it from them.
In India, I would say the cost problem. Like in India, we say the basic need is food, clothing, shelter. But now it is also a basic need for them, a stoma bag. So anyhow, they have to buy it. And some people, because they cannot afford, they normally keep ostomy bag for almost 10 days, 12 days. And because of that, their skin get degraded, or they start having skin problem.
The cost is too high. Surgery is just a part, but post, because it is a lifetime maintenance for you. Once you have this bag, it's lifetime. I know a person who just wraps some, cloth around their bag and they wash it because they can't afford a bag.
So as you can hear, a lot of people are creating their own like custom-made ostomy bags, and this leads to a lot of infections. So here's where we thought, okay, if we want to design this low-cost ostomy bag, what is the one thing we need to get right? So I have conducted a survey that 58 people answered in India, and we realized that the main problem was leakage and skin irritation, which is a consequence of leakage. So we decided to focus really on solving leaks. Those are some of the reasons people say they have leaks. And here's where we said, okay, our hypothesis is that leaks are happening because there's a mismatch between really the body and the adhesive that is going on there. And it creates these little blisters that then connect and create a delamination. Or maybe there's just one big blister that goes bigger and bigger. So this is where we started.
So first we wanted to sort of just establish a holistic understanding of what it means to be an ostomy bag user. And so a couple people on our team sort of did a series of 3 experiments where we wore the bag for a day. We sort of did some everyday movements with the bag, and then also added liquid to the bag to sort of mimic sort of urine deposits. So first, like a day in the life. So a couple of us wore the bag for 24 hours and then recorded our experiences. And so main takeaways of this was that the bag really has varying degrees of security depending on the movement that you do. And then also leakage is a huge problem in general. And so also near the end of the day, you'll experience sort of discomfort in terms of taking off the bag and also just in general skin irritation. And so there's some pictures of me. I think also Manu participated as well. And so another thing that we did was looking at movements, right? So an important thing for the stability is that the bag can withstand these everyday movements. So here are some videos of me and Ivana sort of doing abdominal exercises, just to see if we can test the bag and look at its durability through these methods. And so some takeaways from this is that really the importance of personalization, right? It really depends on where you apply the bag and also person to person, right? Me and Ivana have sort of different bodies, and so the ostomy bag performed at different degrees depending on who you are and where you put the bag. And so the third sort of experiment that we did was actually adding liquid into the bag. And so essentially we added color liquid using just like water with food coloring around like 50 to 100 mils in the bag, and then looked at how that would change the dynamics of the bag using this like added weight and also moisture component. And so there's a video of Ivana sort of having our like liquid and then doing again a series of like everyday movements onto some liquid. Yeah, and so just overall conclusions is that obviously the center of weight shifts, so that makes the bag a lot more precarious. And then right, that affects the physical movement, and then just the additional parameter of the movement of the liquid also destabilizes the bag. So just some other pictures.
Yeah, so then to understand how the delamination process works or how these bags start to fill, we sort of set up an experiment, which is in the back if anyone wants to see it after class. And so basically we used an ostomate bag. We had a simple motor that was sort of going to mimic the different motions that one does throughout the day, such as like bending, stretching, twisting. And then we had a recording system so that we could sort of monitor how the bag was progressing as time went on. And then we used PDMS surfaces to sort of mimic the stomach surface, and then we had different levers that we were using to simulate the different motions. And so we did a couple of experiments, and some of them we increased the repetitions, and then others we increased sort of the amplitude of how much is being pushed. And as you can see, we got varying results. With increasing amplitude, we were able to see a complete failure of the bag. And so we had to process the images, and to do that, Diego from our online portion of the team helped us using ImageJ, and he was sort of able to sort of manually capture the areas on where you can see the bubbles increased, sort of indicating that delamination had occurred. And this is the other experiment where we see complete failure, and as you can see, in that case, the liquid would have fully gone through the bag and leaked out.
So I'll just say something briefly about the theory and the scaling underlying this. So essentially the delamination we think is caused by a geometric mismatch and also an elastic mismatch between the substrate, i.e. your stomach, and the bag itself. That the human body has curvature to it. The stomach has what we would call Gaussian curvature, where it's curved along multiple axes. And in general, this causes issues with adhering an initially flat state, which has zero Gaussian curvature. And there is some degree of strain that is induced by that you are sort of forcing the bag to either delaminate or to stretch. So we have some examples. There's a pretty rich existing literature surrounding delamination of a sheet on a sphere, right? Something that has curvature. And you can see some examples with, a standard Band-Aid on someone's knee as they're flexing their knee. And you can see these kind of familiar blistering patterns forming. That one on the bottom is a sheet on the surface of a glass sphere. And you can see, again, these blisters coming in from the outside. I will say very briefly regarding the scaling that essentially you can consider a competition in the energy between the adhesion energy and then also the elastic energy of the bag, that you can talk about the strain of the bag based on the curvature of the sphere and then the radius of the bag itself. And so we can write the total energy density as this competition between adhesion and then these bag elastic properties, the scale of the bag versus the sphere, and then also the stretching modulus of the bag, which is this capital Y. And if you do a quick rescaling into non-dimensional units where you have this competition between the sheet size and the sphere size, and then the adhesion versus the stretching, what you see is that the naive prediction is that you're going to get a rough balance between these two things, where you expect delamination to start setting in at about this beta to the 1/4. However, this is sort of naive because it's not including the fact that the sheet is going to stretch differently in different areas. So you can do some more math and you can get a different prediction, which is covered up by the Zoom. So I will say very briefly, this inspires us to instead consider an annulus rather than a sheet on a sphere. And we'll do some future experiments on that.
Yeah, so just to sort of conclude, right, where do we move from here? So we sort of are planning on thinking about different geometries. So, right, as Ben said and talked about the theory, we want to sort of look at how do we, fix this problem. Potentially, we add sort of additional materials and adhesive materials at different spots. We can play around with the shape of the bandage, right? It doesn't have to be a circle. And so also just testing this with additional movements to see where the failure points are.
And then also standardizing our image analysis, potentially working towards a more unified way of analyzing it with Python or other softwares. And yeah, so in general, we just want to thank everyone, including Vivav and Diego from the online team, and just in general, the Frugal Science teaching team.
One burning question. Yes.
I don't maybe I missed, but you mentioned that you tested like water. Did you have like a metric of like what level would you think was like locally up impact? Is it like 0% at all, or was normal up impact?
Yes, so she's asking what it's like the ideal reduction of leakage for people. So you need to imagine that these people, a lot are actually isolated at home. They don't even want to go out because they're having so many leaks. So even having a small reduction would already be a huge difference for them. But of course, we're aiming at having like maybe, yeah, more than 50% reduction would be already huge.
Because remember, a leak once is then depending on the volume that comes out of the body. Leak is a failure. So even if there's a small pore, that is just gonna, it depends on the amount of liquid that's in the bag will determine. So, I think the goal should really be is that this is absolutely, it's like the same way as if you have a gas stove, there should be absolutely no leak. That's kind of that's the target that we should shoot for. This was fabulous. All right, let's keep moving. Next is the sanitation team. Tushar, you're online, right?
I am, yeah.
Okay. Yeah.
Yeah, so that's a slide. And yeah, we were focusing on open defecation. And so basically, this is like a very prominent issue in like developing countries, and like especially in the areas which are like low income, like rural areas. And then this problem itself like leads to other problems like water contamination and spread of like diseases like diarrhea and cholera. And as we were like thinking through it, we realized that there's like no one way to solve this problem. Like in order to solve this, we have to cover like multiple aspects. Like you have to spread awareness, and then we have to provide them with like sanitation facilities, and we have to foster behavioral changes within the community. And in India, in order to tackle this issue, the government of India launched a Swachh Bharat mission in like 2014, and their aim was basically to build toilets across India, and like they were giving this incentive of about like 1,200 rupees, and out of that, each household like gets that money who don't have who don't have access to toilets, and they basically like build a toilet out of it. But we realized that the money which was given was not enough, because first of all, it was not enough to create a toilet alone, and then after that you also have to like maintain it. So we're just trying to go through after this like why it sort of failed, and we realized like these were like some of the major points for its failure. The very first point was like poor maintenance. Like we also realized like even though they have the toilets, there's no proper sewage system or like a centralized sewage system for it. And then they have this behaviors, like they're into this habit of open defecating like ever since childhood, and it's like hard for them to like leave it. And then water scarcity was also another challenge, because a lot of these toilets like depend on like gravity. So you basically pour the water and like it basically goes down like the drain, and uh it's not properly cleaned because it's like dependent on gravity. um And then, Tushar, do you want to go through like the last 3 points?
Yeah, also we have this problem of lack of education. So the thing is, like, a lot of people lack information about, what happens if all those diseases spread. Like, I read one article wherein, one person mentioned that the person's daughter got diarrheal diseases, because of which she had to be, like, in in and out of hospitals for like 2 months. And like a lot of people would say that, okay, it's just, like, you just have to go to the washroom and it'll be fine and stuff. So like people don't take those problems seriously. They just think that it's temporary and stuff. Right. Another problem is communal indifference. So a lot of people, like, like, for example, if a public toilet is created, people will be like, okay, why should I clean it? Why cannot my neighbor clean it? Right. So there's this lack of sense of unity. And one of the most prominent ones is definitely the conservative beliefs that people hold. Like, okay, I can't have a toilet in my house, where they are got deities and stuff, right? So such beliefs are, holding people back from investing in such toilets in their house. Yeah, that's go ahead.
And then we found few data like so we started with Haryana. We started like focusing on Haryana first, and we realized that out of like there are only 80 toilets for like 10 million women, which is like very less toilets, right? That doesn't sound good. And then like 10% of the children, they died due to diarrhea in 2011. And yeah, like the sanitation is like one of the major issues for it. In India, there are like 1.4 billion people, and like 800 million people of them, they lack access to safely managed sanitation. And in 2020, over 200 million people defecated openly, which seems like a huge issue. And then yeah, this was like we found out that a lot of especially girl children, they like refuse to go to schools because they don't have like the schools, they don't have like proper toilets, so like they don't even have one. And yeah, I already talked about cost of maintenance, like how the like Indian government, it provides like 12,000 rupees, and that's not enough. So that was also like a major issue. And then 1/12 of the like feces which is produced in the world is not managed properly. So that was also something which we wanted to consider as we like try to like tackle this issue. And these are again few data. We made some assumptions that you need like 20 by 20 inches of area to build a toilet, and the people who defecate openly, like they contaminate like a huge part of the land. And then this was another assumption we made, that if a person say uses a toilet for like 15 minutes, and on a daily basis, if it is used for like 8 hours, 32 people could use it. And then we got data that in Haryana there are like 17 wards of village, and then each ward has like 10 to 15 houses which don't have toilets. So we just assumed that's like in 17 wards there could be like 170 to 255 houses, and if each house is like 3 people, then about 510 to 765 people don't have like toilets. And yeah, this was like a table which we had, so we thought that we have to focus on maintenance so that people tend to use it more. It has to be affordable, as cost was a major issue. It has to be effective in terms of like there should be no odor, it should be clean, and it should be sustainable because water was also an issue. And then so we thought of coming up with like a vacuum assisted toilet. And yeah, so that's do you want to continue, Tushar?
Yes, so we don't have much time, so I'll just quickly walk you through this. So there are a lot of problems, right, that we just talked about. So we thought of focusing on the primary one, which is the maintenance, because like even a lot of people mentioned that toilets are created, like the government has created millions of toilets since 2014. But the thing is, those toilets, they get created, but they are abandoned because no one is maintaining them. So we thought of creating like there are multiple parts of the solution. So we'll have to first, create a flush system that sends all the toilet into some container or something so that it can get treated later on. So for this, course, we thought of focusing on the first part for the toilet to go inside a container. So what we thought of was developing a vacuum system that will pull the waste down inside a container, whatever it is. So yeah, can you go to that earlier one, Daksani? Yeah, yeah. So we
brainstorming through it and like coming up.
Yeah. So we looked at like different flush systems that are used, right? So they are pressure assisted, gravity assisted and stuff. So we realized that the vacuum assisted ones are the ones, that are really good for us. So we started brainstorming on different designs, making it compressible and stuff so that yeah, basically that. So what we ended up with was we thought of designing a system, a flush system that would work on people's weight. So let's say a person comes and sits on the body of the toilet. As soon as they sit on it, the flush system activates. So as the person is, producing waste, the waste is getting flushed, right? And it's getting treated. And when they get up, then the flushing is done, and the next person can directly come in. So for the first part, we thought of like as soon as the person sits on it, because of the weight, the flush systems would get activated. Now, since it's vacuum assisted, so the weight of the person is used to create the negative pressure inside the toilet body, right? Yeah. So this is sort of like a rough diagram that we drew. Can you go to our next slide? Yeah. So next one, please. Yeah.
Okay.
So yeah, we designed a very small prototype. So we have this box, and then we attached a syringe, and we have two valves. So we use unidirectional valves, such that the air from the container flows outside, like through the syringe. Like when we pull the syringe, the unidirectional valve opens up, and the air goes inside the chamber of the syringe. And when we push the push the piston, then the other valve, it opens, and the air goes out without getting inside. So we did not have a pressure gauge, so we did not we could not quantify the change in the pressure, but we did make some observations that allowed us to know that negative pressure was created. So can you go to the next slide, please?
Also, I just want to mention that we were like,
Yeah.
so to create this model, we definitely needed like two valves, and we were thinking of like what can we use, and then all of a sudden it came in our mind that we can use like the N95 mask. So basically, we use like the valve in there to kind of create the prototype. Yeah.
So for the valve itself, we use different materials. We tried different materials. We use banana pills, we use balloons, plastics, tapes, and stuff. So a lot of them did work. Banana pills, they work very well, but the problem is it's organic, so it just gets dried. So ultimately, we ended up with going ahead with balloon cup layers. Anyway, we made some observations, and then we realized that when we, uh, like got the system running, the container, it became rigid, right? And then there was water vapor that was getting built up, right? And it was getting hot. And then we had put a balloon inside the container, and then we checked if it was getting shrunk. And then when we, took it out, like for the first few seconds, we did realize that, it was shrunk by just 0.2 centimeters. It's very less, but still it was, something. So yeah, so it worked. Basically, the negative pressure was created, but it was very not very efficient. Can you go to the next slide, please? Yeah. So we realized that some of the things that we would want to work on for the future would be making sure that the valves work very well. There's no leakage in there, because apparently there was some leakage. And then the tube that we used, it was very thin, so we had to pump about 300 to 400 times, just to create that negative pressure. So we want the pumps to be the tube to be larger, and to have a pressure gauge so we can quantify the change in pressure. Yeah. So that was the first part. We are done with it. We'll just optimize it, and then we'll build a biodigester and attach it with a filtration system that will, like the filtration system that is used in spaceships. What they do is they separate solid and liquid, and that's what we'll try to do. Separate the waste and then treat them individually, and then ultimately create a decentralized, sewage system.
Yeah, like
Yeah,
a lot
that's
of the
it.
ships, they have like this huge tanks in which they have the bacteria, and they basically use that bacteria to sort of, you know, process the waste. So that's what we also thought of to like include, so that since like sewage thing is like a main issue, so we can like create something which is like decentralized, and that can be done. Also we would, so also like we experimented to create like the valve of the mask which was there. So we basically used these two caps and made holes, and like there's like a balloon inside. It's not like working properly, like it's not like, yeah, it's not like fully one directional, but then it's sort of working. So we will try to improve it further. And like in like further, we also want to include this biodigester thing and like filtration system in there. Yeah. And that was it.
Thank you.
Quick question. I don't know if people realize I mean, you've all taken flights. The inspiration is really.
If you like blow air through it from one side, it'll like,
Vacuum is actually used and not water.
what do you call it? It'll open, and from the other side it'll like
Have
close.
one on Zoom. The question is, if you have a child or someone really light, could you make people physically pump before?
We definitely thought about it initially, but we were like, let's focus on like, like the major not, yeah.
But you could just find I think the biggest issue with toilets in terms of maintenance is you don't have water. So this kind of, sanitizers have become really interesting in schools now, in terms of thinking about not having water, but having water to flush is a huge issue. Yeah, I love the fact that you guys actually built a prototype because that is fantastic. One of the things to also think about is all local materials, because it's a type of a project that has to be driven bottom up. So thinking a little bit about making these valves itself. Okay, let's move to the next team.
The water flushing machine.
I guess this is the atmospheric water, atmospheric rivers. How are we doing on time, by the way?
We're a little behind.
We're okay.
We're a little behind.
Who are the people in the very end?
Got it.
Some
Antibiotic.
people have a hard stop but you've already given your thought, so that's okay. Everybody else is a little bit okay? We run 10, 15 minutes late.
Yeah. Yeah, what do you want to speak up?
I don't want to intervene with anyone else. I asked if I could be late to my class, but I didn't think it'd be too much late. My class says that, I got it.
I don't think you're gonna.
Yeah. But we can bump you guys a little bit up if the other team should be okay. Are you guys all the way at the end or no?
Yeah, they're the last few.
Yeah, I see.
Does anyone have an objection to being down one spot?
If people don't have a virgin thread, then we can move you guys up. Yeah, just do that. Let's do it right after this team. Yeah. Okay, take it away.
Okay. Our project, it focuses on the water atmospheric vapor entrapper, or WAVE. So water scarcity is a huge issue, especially as climate change and increasing population causes more drought and increased demand for water. And so these are some of the statistics that are that we want to highlight, that 2 billion plus people live in countries where water supply is inadequate, and that 50% of the world's population could be living in areas facing water scarcity by 2025.
Sometimes it makes that
Not just talking about water. We started pouring water.
And we specifically were targeting the population in Western Cape, South Africa, which faces extreme water scarcity, with 19% of the rural population lacking access to a reliable water supply. And also in 2018, there was a situation called Day Zero where the Western Cape almost ran out of water and they almost shut off like municipal water supplies and were considering starting to ration water out. And I think this highlights an important issue, which is that the water crisis is not just a health issue, it's also a socioeconomic issue, with it disproportionately affecting people living in rural areas and who cannot afford to pay for their water.
All right, so it's just to piggyback off of what Marisol already said about the existing problem. So there are current companies, many companies actually targeting this issue. So many basically solutions exist within this claim, but a lot of it has like fundamental limitations. So for example, if you're looking at this plot, which is basically relative humidity with water output, for something like fog harvesting, where you literally put up giant meshes, I think someone posted this in Discord, you can capture a lot of water. However, the optimal around relative humidity is actually around 90 to 100, which is not feasible for many places. So there are some other options, such as using a desiccant wheel, which is this giant industrial wheel with desiccants embedded into it that basically spins, condenses, but this uses a lot of basically energy input, as well as these are very large scale commercial products. So what we have here is this is scaled to 1 kilogram of desiccant. For reference, what we have in front here, this is around 200 grams. So a lot of these wheels, they claim they can output like 100 liters of like 100,000 liters of water per day, but these are huge machines that basically take up entire room. So what we're kind of targeting is this region in the middle where there's not great technologies currently. And then this region, it might seem like, oh yeah, like why do we care? But more than 1.2 billion people actually live within this region, have water scarcity issues within this region. So that's what we were hoping to target, especially like given this graph of temperature versus also just relative humidity, we're targeting semi-arid regions. So what do we actually want? We basically want a highly portable design. As you see, we can just transport it really easily from the back of the room to here, a highly modularized design that is essentially biphasic. So, or bimodal in some sense. So we wanted to operate both within this kind of like arid, kind of like seasons, as well as during the humid seasons, so that people have water year round. So part of it is we're gonna rely on just like kind of like an I guess like metal framework or iron mesh where you basically just fold it into the wave structure, hence the name wave. So that could just be in the box during the relatively humid seasons where we don't actually need any additional input. Basically, you just put the mesh out there, it gathers water, you collect the water. However, during the drier seasons, we're going to implicate this like desiccants, basically that are then overlaid over it, such that you can basically take it off, put in as many as you need, depending on what condition or what kind of like relative humidity you're targeting. And the whole idea there is with the desiccant, it's kind of relying on this day-night cycle. So during night, we're basically opening this lid comes apart, where you basically just absorb water, put this in a place where you think you have the most airflow, where you have the most relative humidity. During the day, close it, use evaporative cooling such that the water, I guess like that is captured by these desiccant beads, then condense onto this lid and then gets condensed out through this white tube. Or can also just be poured out from the bottom. So we have two basically collection methods, one where it's just passively pooling at the bottom, one where we're actually trying to actively condense it here. So to increase like the thermodynamic, like I guess like cycling and efficiency of this machine, there's also a fan here in the back. This is just a 3D printed fan that basically during night, it helps with the cooling. During the day, it basically allows for airflow such that we're not just like oversaturating the water pressure in here or water vapor in here and nothing actually condenses in that sense. And everything here is just a solar panel, which is actually pretty cheap. So as a proof of concept, right? Like the main part of our thing basically relies on you have the grid and you also have the silicon beads. So we were trying to think, okay, so how do these beads work? So we set up this pretty simple experiment where I basically spiked in like certain amounts of water into this tissue paper, or it's just that paper in the back, put it in here, basically leave it there for a day, which is what our cycle is simulating. So what actually happens? So the beads that we're using specifically for our proof of concept are these color changing beads. When it's dry, it's kind of like this blue color right here. When it's like wet, it basically changes into pink. So that was basically after capture, and this is when we're trying to actually evaporatively heat it. So the main goal here is we basically use solar heating, right? Any sort of reflective surface put on top of it, make a really easy solar oven. If you have tinfoil, that works great. If you have a mirror at home, that also works great. And what we did here is basically just heated to roughly the temperature of a solar oven could achieve. And then what we see is, wow, we have condensation and wow, the color changes back. So basically works out.
Condensation is fantastic.
Yeah.
There is water.
We were really surprised at how much we were actually able to get out of it.
It's actually quite a lot of water.
For sure. So basically this is a really basic graph, like as you're increasing in relative humidity, or I guess like in terms of the quite literal humidity conditions, the water that is gained as well as the water that we're able to recapture is around like 30% within the semi-arid zone. And for reference, the relative humidity here is, you go to the next slide, roughly around like this 20% to 30% range. So we're actually doing pretty well. We're a bit below the industrial desiccant wheel, but on the, I guess like the scale of the household, which is what we want our device to be for, it's actually like a decent amount. And then as you basically put in more desiccant, we're expecting water input or output to basically increase as well. And as Marisol mentioned before, we're not only trying to alleviate like the health issues, it's also kind of a socioeconomic gap in which I guess like individual households, especially in rural areas, don't have access to. They have to basically ask like these centralized agencies for water. And we're just saying, hey, can we maybe supplement that with a bit of like technology in your own household?
Okay, so moving on to our build versions. So our first version, we just had the desiccant layer flat, and we did this for like testing purposes, just to, well, first we created this like test environment where we put a humidifier in an enclosed box, and we kept our device in there for about 5 hours, and you can see the change from blue to pink. Let's see. This was like when it was pretty humid in there. And you can see like just some water pooling. And then this picture on the right shows the metal. You can see the droplets formed on the metal, which shows pretty effective in harvesting those, the dew droplet things. Oh. Okay, so then next we took it to the hot room, and you can see that it pretty much dried up any water that was in there, and like, yeah, I guess evaporated it. And we took it outside. This was at night, and within 30 minutes, you could already see condensation forming on the slant of the glass as well as at the bottom where the wiring was. Yeah, it's kind of hard to see, but there's like water droplets like on the bottom that fell from the mesh. This is just another video kind of showing what the condensation looked like. So it happened pretty quickly after we took it out of the hot room, and just showed how effective like the passive cooling method is. And we tried to collect some of the water, but it was kind of a bit difficult with our setup.
Yeah, at that point we hadn't used the collection.
Yeah. And also just, I guess, to note was like, usually this would be done over a span of like 24 hours with like the beads absorbing moisture during the day, and then at night, the condensation occurring. But we were able to do like collect water within a span of 11 hours, obviously with some simulated environmental conditions. But next was our second build version, where we kind of updated a few things to really maximize like harvest efficiency. So we had the corrugated desiccant sheet, which increases surface area of the desiccant, so we can maximize how much like air that the desiccants are able to come into contact with, which is also the solar powered fan. And then having a white collection tube and collection jug to increase like reflectivity and amount of time spent in passive condensation / like cooling mode. And then also having a reflector that increases the heat directed onto the desiccants to improve like evaporation, which would lead to condensation. Oh wait. I don't know if I don't think we have time, but basically these are just videos showing that we got the motor running to get the fan working, and then also the solar panel, we hooked it up to a separate little fan, and it was able to like get the fan running. So we weren't able to like finish that part, but some proof that that worked. And last, our next steps is just to evaluate like the optimal desiccant. There are a ton of different desiccant like formats, and we want the most efficient one. And then also changing the angle maybe to like improve collection of the condensation. Lastly, testing like efficacy with like all of our components combined, and also like adding a filter so that the water is actually like potable.
So the evaporative cycle is a frequent cycle. So as long as the system doesn't grow mold and dissipate, clean it from time to time. Also, just the desiccant is a reusable material. So you get to tune and change. It's not as if anything is consumed. Technically, nothing is consumed in the system. So you can, your cost analysis can change based on if the unit operates for a year. If you want to just increase the higher throughput, you could use more desiccant to change that around because there's no consumable technically. I was super awesome to see those droplets. That kind of was I was a little worried in terms of whether these desiccants are too efficient. Any questions? Yeah, I think one thing to do is this is a classic thermodynamic cycle. So you should really write this as the delta T between the total system, the delta humidity between the two systems, to be able to say as you run it as an engine, the energy taken in, what does the power output look like? So this would be a really beautiful, proper model. Rita, is there a question? No. Let's switch. Do a little change in schedules for the team. Kind of figure out the tent heaters. Yes. Where are the donuts? Some donuts were promised.
They're
I
outside,
sent
but
that out to people. Are there donuts at the back?
They're outside.
Oh, they're
We're not
outside.
allowed to eat in here, so.
Oh, we
grab
can't eat
some-
here?
You can grab things on your way out, and if you have time, hang out.
Oh,
there.
yeah, maybe we'll do donuts and planning for what comes next.
Yeah.
Posted. Okay, heaters, take it away. Don't you guys want your prop up front? No? Of course, no? Otherwise, most people haven't actually seen. I'm thrilled to see, just the progress you guys have made, even in the last 2 weeks, is amazing. Okay, take it away.
Hi everyone. The solution that we worked on was low-cost tent heaters, and a bit about the problem that we decided to choose. Over 500,000 people in the U.S. experience homelessness, and there are thousands of deaths and illnesses related to the cold, both in housed and unhoused populations. And looking at these two issues and kind of the systemic injustices that exist, we wanted to focus on improving comfort and safety for those experiencing homelessness in the US through a harm reduction tactic. The current solutions that exist on the market for tent heaters cost over $100, and they're from REI. They're also pretty bulky and very prone to being swept by the police, which happens pretty often in homeless encampments, at least in the US, and are also prone to being stolen. So also current solutions for those experiencing homelessness and who cannot afford to buy a tent heater. The first go-to is on the left. I don't know how well you can see it, but people will try to insulate themselves from the cold. This is through found material like cardboard or blankets or clothes, just trying to keep themselves off the ground so that they're not exposed to the direct cold surface. But aside from that, a lot of homeless people will resort to burning materials such as wood, trash, and grease to heat their spaces. Not only is this super dangerous because of the fire hazard, these also produce fumes that totally deteriorate their health, and it's just not a long-term viable solution. Oh, and one more thing on the last slide. I think there's this common misconception that for those who are experiencing homelessness and who are at this kind of risk, they should just go to a shelter. And this is not really a solution. On the West Coast, shelters in major cities do not have capacity for more than 50% of the homeless population in these cities. So there is simply not enough capacity, and this is not really a solution for homeless people because they're not able to bring their belongings with them. If they have pets, they're not allowed to bring them into shelters. So solving this issue of heat for those who are actively out in the cold is a pretty pressing issue. So we happened upon this initiative called the Heater Block Initiative. This was created by an anarchist initiative where there's no organization to this. They developed this very thoughtful guide that walks you through how to use easily accessible materials to produce very low cost heaters that are safe for tents because they don't produce fumes as they're alcohol burning, and they have some built-in safety measures. So last year, Henry and I worked on building some of these and passed them out at People's Park in Berkeley, which has unfortunately now been shut down by the police, but was an encampment that existed for many, many years. And yeah, we worked on improving this solution in this class.
So really, what is this solution? It's an alcohol burning heater, and how that works is it has a few parts. It has this copper coil, it has a wick, and then it has a reservoir of fuel, the isopropyl alcohol. And so the wicks will soak up the alcohol, and then as you heat you start it by heating the copper tubing, and as the copper tubing heats, it causes the alcohol to evaporate, and then once it evaporates enough, it catches on fire. And then you kind of see in this feedback loop that when the flame ignites, it keeps heating the coil, causing more fumes to form, and therefore feeding the flame. And so it's a really cool method in that it's self-sustaining. And as long as everything's working properly, it'll keep going. And then in order to blow it out, or in order to turn off the flame, I forget the word, sorry, extinguish the flame, you can just blow it out, or if it falls over, it'll also extinguish. Okay, and so some challenges with the original design, based off of our our assembly last year. For one, it was not portable. It was very clunky and fragile. And with people who are housing insecure, it's very important that you're able to carry as much of your belongings as possible. And we felt that you shouldn't have to sacrifice heat because it was too clunky or difficult to carry with you. And the next, sort of, when we were making these, we found the flames that we were getting were very inconsistent. And so for one, if they would light, they would slowly fizzle out and extinguish by themselves. And then additionally, if it was consistent, it would be pretty much just a glorified hand warmer. It wasn't really meant for cooking or like substantially heating a tent. And lastly, we wanted to improve the assembly. We found that it took several days to assemble, and that was purely because it was waiting for things to dry. And so we wanted to sort of eliminate some of that. And then sort of going more into the issues that we found this quarter in making it. We saw that weak flame, and some possible causes of this. We thought that the flow rate of the IPA might be lacking. We find that might be caused by some blockage formed during assembly, or the material used for the wicks, and then some other things. And then once we got it working, we found that there were more issues with overflow. We found that after you lit it and then extinguished it, it would start leaking IPA, which we found was possibly very dangerous should you go to relight the system. And so we did some testing, especially on the wick. We did more testing than this. It's just that this is the best documented one, I'd say. And so we wanted to compare different wicks and see, for one, how can we maximize the flow? Because at this point, our most pressing issue was that the heater just wasn't working and it wasn't lighting. And so we did several different materials, kind of sourced from some just like from the paper towel dispenser over there, or some from old clothing, or some from old towels. So we really want to focus on the reusable aspect of some of these materials. And we found that the cotton towel worked the best. And then
So through all of the work that we did, we were able to make some improvements to the design. So to begin with, one of the important parameters was the portability and how clunky and fragile it was. But now we have a more compact design that is much lighter than it is before, because we have this base that is 3D printed and it's just much lighter than a porcelain plate. And to the issues of the inconsistent weak flame, now that we have understood the pump a lot better and have better materials to improve this, we were able to create more robust flames
and as you can see in the pictures. And then lastly, a big issue was how long it took to assemble. So here we have 4 days of inactive work time to have this setup work. But now by using either a 3D printed base or air drying clay, which is unfortunately covered by the Zoom thing, we reduced that to 1 day. So we can go to the next one. These are, yeah, okay. Let you guys watch. So on the very left, we're seeing how long it takes to light. And because of time, I would say that we brought it down to like, it used to take like maybe 1 minute and 30 seconds to light. And now it's
over 2 minutes to light, which is more wasting. It's wasting the lighter like fluid, and so everywhere we can cut costs, we try this as much as possible.
And also if you're in a tent and there's a lot of airflow or something, it's just never gonna light. But now we reduce it to roughly 20 seconds. Okay. And then the flame is just much bigger here. And then we got to 500 degrees C, so that's great. And
oh, sorry.
now for future goals, now that we've focused a lot on the pump itself, the next parameter that could be optimized would be the radiator or the pot that is on top. So using like the Stefan Boltzmann equations, we can think about increasing the emissivity of the pot, maybe use the black one instead. You could increase the surface area, or we could just simply use different materials that are capable to have more heat exchange, such as, for example, stainless steel. And ideally, we would want to decrease the assembly time to even less than a day. That would be another parameter to continue optimizing. As you can see, the flame is very, very large, and maybe this is also not the best thing. So improving safety there would also be ideal, and continue to improve things such as transportability and the reduction of size. So thank you, everyone, for everything. So
we'll just put it back on the
Plane. Yes, let's watch that for a second. Questions, burning questions. Yeah, got this one. Yes.
See how you made it a lot better. I guess my one thing is like, it makes sense where like this is better for like if you guys want to create it in for the purposes of like being able to create it at home. Like it seems like the original is like more complex, but like I don't know how so much like
right, absolutely. And I think a lot of these, like the heater block initiative, is mostly people who have the resources making these and then distributing them. But that's also why we considered the air drying based clay.
you can buy this for like a big pack like this for maybe $10 or less at Michael's, and then use maybe like a sixth of it. You flatten it out, cut a circle around it, and stick the cage on it, and then let it dry.
I think one of the functional requirements is every single part in that thing is fetchable by a person who's looked around.
And so we definitely continue working on that. And hopefully we can reduce some of the other, like make some of the other things easier to make. So like getting a copper coil and like bending it, that might not be accessible, or the epoxy to seal the copper tubing to the can.
Figuring that hole,
Yeah.
figuring out a way to drill the hole.
And the goal of this is for like a group of people to get together with like various skills, and so and produce it. So yeah, like some of these collectives that exist like Philadelphia, New York, like they can't make them, it's just so cold. And they do like 3D printed bases and like
So then if we can improve their design, that would be fantastic. Any other questions? Yeah, safety more broadly.
for one thing, if this heater falls over, it automatically extinguishes because the fuel
That's in the
is
pump.
flammable, but you can
Additionally, there's this isn't shown, but if you see in here, we designed it so that there's this pocket here. We didn't get to it, but hopefully we could mix some cement and then just pour it in that mold. And then it'll be heavier, but it'll be more controlled and geometrically like uniform, I guess.
I should do some of those topple overs they can test that
Yeah.
out. I'll find a space there.
It's hard to test with these flames just because of the university's restrictions and regulations. And then when testing here, like with the proper filtration, yeah.
Okay, let's switch. Yeah, and then if people hang around, we can light this up. Also for all the other projects, if somebody wants to try the ostomy bag, like once the talks are over, there is donuts and coffee, and we can actually try some things out.
How do
What's this thing about not being able to?
I think Sorry, I thought there was a plug-in. So, we're gonna leave it on that. Okay, good. Okay, cool. I hope you guys can hear me online. So they just talked a lot about heating, so I'm gonna talk a little bit about the other side of the problem, which is cooling. So my project was spent working on eco cooling, so understanding green technologies that could better control temperature. Um, so the current problems with our existing cooling technology is that it's very high energy consumption, it's quite expensive, and they often use harmful materials. So to give you a little bit of perspective, residential ACs can use about 2,000 to 5,000 watts per hour when running. And in the US, air conditioners count for 12% of a home's annual energy consumption. And oftentimes it can be because they're not exactly efficiently designed, because that wasn't something that the designers were designing for, but rather just to give their customer the maximum cold temperature. And then the AC can cost, even just not a central AC, but one that you want to put in your bedroom, can cost from upwards about $1,000. So for countries where the average monthly income might be $30, $50, that's highly inaccessible. And then the harmful materials, oftentimes air conditioners use refrigerants, and those are known to have a high global warming potential effect. So overall, there's a lot of improvement, in my opinion, with these technologies and the ability to have a largely positive impact. So to give you a little bit of understanding of the numbers, currently there are 3.6 billion people who already live in areas experiencing dangerous heat. And this is centered around the equator, but more and more it's not limited to that. By 2030, it's expected to grow to 50 billion, or sorry, 5 billion, 5 billion people. And this number is expected to just keep on growing, especially towards 2050. You'll see a large jump. But also 5 billion by 2030, that's just 6 years away now and not as outlandish of a year. And then about 2,000 terawatt hours currently go to power fans and AC, which can sound a little bit like a weird number, but typically the average nuclear power plant produces about 1 terawatt hour. So this is, if we had 2,000 running at full steam, this is what it would go towards. And this is about 48% of the total annual electricity that the US uses yearly. This is a worldwide number, but just to give you some perspective, that's what the number looks like. And I wanted to talk a little bit about the history of cooling to give you an idea of what has been done in the past. Because I think, honestly, there's a lot of innovation in the past that we've kind of strayed away from with the wonderful invention of electricity. So on the far left, that screen that you see is called a jali, which you'll often see in old Indian Mughal architecture. And it does a really great job at preventing some of the heat coming through from sunlight and also allows for wind to pass through. And then up above, you have a termite mound. So termite mounds are used a lot by building engineers as inspiration. And one of the ways they do that is by using the simple principle of hot air rises and cool air sinks. So they have certain ventilation shafts. So when the wind is blowing in, the cold air will come and cool their whole system, and the hot air will continue to rise up through shafts that they have at the top. And then the bottom picture that you see is kind of one that Manu told me about, which I thought was really interesting. But this is called a panka. And what is happening here is on the left, you see slaves, which are standing almost entirely outside of the room. And this kind of occurred in colonial India. And they would pull these huge cloth fans to cool down the room. And this started off as like inspiration from the handheld fans, and they made it more industrialized and used a lot of intensive labor. But they were quite efficient and cooled down large rooms. And as you can see, it's a fairly simple design. And now with electricity, you don't even need someone to pull it necessarily. And then the last thing I wanted to talk about was in China, because they're in the northern hemisphere, they build their houses, or they did build their houses facing south so they could maximize the sunlight while reducing the amount of like specific direct light, which results in heating up their home. So these technologies have been around for a while, but have grown a little bit outdated. So I thought a lot about that and started to design my project. So I was specifically keeping in mind the global south when I was designing. So I was using my personal experience, like visiting India and going to my grandparents and seeing like the continuous struggle with heat. So some of my functional requirements were to cool people at least 10 degrees Celsius, use less energy than an AC, doesn't need language instructions, like simple photos, so can be installed really easily, costs less than $20, and then can be transported on a motorbike. So I began by researching the different designs, and then I created a Fred Park, and then I began to do some prototyping, and then continued on. This is kind of the overall trajectory of my project. So the first thing I did was design. I thought about different fans that existed. And learned that there's axial fans, centrifugal fans, and then decided to focus on this specific kind of axial fan. And then I was brainstorming different factors that can influence a fan's efficiency. And so the way that I did my experiments was by focusing on one specific variable and tuning that and testing it. And so the first variable that I decided to test was the size of the fan blades. As you can see, I had some early drawings with different numbers of fan blades, but ultimately I had found prior research saying that 3 was the optimal number. So rather than start completely from square one, I started to grow from there. So the first hypothesis is, do fans with a larger diameter move a larger amount of air? And this was basically one of the first questions I asked myself, and I designed them kind of simply on CAD and just had 3D printed them. So this is a fan blade of about like 2.5 inches, and then this one I was about 1.7, and then I had a smaller one as well. And then I used an Arduino to control the specific speed. So that was kind of the code that you see there. But if anyone wants to see, it's a very easy demo. So I figured I'd do it during this.
The fun if we can feel the breeze.
All the way from there, I hope.
That the blades are not in the direction that you would intuitively think about.
Yeah.
The most common fans that I'm used to, the blade is cutting. In this case, the blade is actually sticking out.
Oh yeah, the
You see that,
angles.
right?
Yeah.
Is that what you meant by the centrifugal and the second fan type that you said?
Yeah, so to design this, I was looking at industrial fans, like ones that you might find at large warehouses and stuff, because they have a large incentive to use more fans because they have such large spaces that they want to cool down. It's easier for them to use this than air condition the whole room. So that was kind of the inspiration for these designs. Yeah, and they're also at an angle, so I figured I'd give it a try. But those were some of the preliminary tests that I did, and I had a anemometer that I was using to collect how much the airflow was changing, and so that was giving me a result in feet per minute that then you can just convert to cubic feet per minute using some calculations online. And then I found that the average speed for this one was about 59 feet per minute, which was I expected more from the 1.7. So I think from now that I've determined like 3 blades is good and like larger is somewhat better, I'm gonna tweak the angles and the actual design of the fan blade next. So that leads me to some of the future experiments that I'd like to do. I'm still really interested to see the punka method, which is using cloth and not necessarily the metal that we're used to. I think that could have a pretty huge effect in cutting down costs. So that's something I'm interested in answering. And then I was trying to design different types of fan blades. So that's another version on CAD that I had been working with. And then one interesting part of the problem that I thought was because one of my constraints was to be able to transport it on a motorbike, I wanted to figure out a way to have this modular, so have it kind of like puzzle pieces, so you can like build the fan size to completely take up as much space as you could in your home, without having to, oh, time is up. Okay, without having to take up too much money to transport it. But yeah, that is my project.
Just a quick comment. Can you say the one comment about the really large? I know you saw some patents.
Yeah.
For large fans.
Yeah. Okay, yes. So there are these really, really huge fans with 15 meters and insane diameters that a company produces. They're really interesting. They use a lot of fan blades, but because they're so large, they move a massive amount of air. So they often take up like the max diameter that could go up in a building. So that was the inspiration for this project because those fans can cool down the room like 10, 15 degrees Celsius, which is huge in my opinion. But they're unfortunately very, very expensive, like costs $8,000 on average. So not, yes.
Great memory on directionality and how it affects the cooling. Can you tell me something about that?
Yeah, so counterclockwise fans draw cold air or keep cold air down and warm air up. So that's why in the winter times you'll see people like changing the direction of their fan, which is yeah.
Chirality of the fan
Yeah.
changes what you keep up versus down. I have to convince myself that that is true. Okay.
Yeah.
A lot more discussion of this.
Yeah.
That,
It's cool.
Yeah.
Any other questions?
Okay.
Cool. Great.
Next is Blake. And then I know some people have to go, but it would be very nice if other folks can stay. Unless you really have an urgent class, please try to stay because we'll have a little bit of a discussion about what comes next as well.
If you have to
Folks that are leaving now, please follow up with me just in terms of project next steps. Yeah. Okay, Blake, take it away.
as a preface, mine is not as artistic as some of the other presentations, but hopefully it can be just as impactful. So my project was about refugees, and then more specifically using AI-assisted dermatology diagnosis with images. A little bit of a background, and then for the population, it was for Zaatari refugee camp, which is the world's largest Syrian refugee camp in Jordan. And yeah, so this is like a satellite from the top. Yeah, so it's about 80,000. I think at its peak it was like north of 150, but it's gone down a bit, but roughly 80,000. So that's like a satellite image. And then a little bit of background. I worked there on a medical mission the summer after my freshman year. And so the picture on the left is actually with dermatology, and then the right is that's surgery. So I was in the camp. I saw that there was a dire need, and that kind of motivated me to get into to want to do this project. And oh, this is also a short video from when I was there. So this is June 2022. Yeah, so like you saw it from the top and you see on the bottom. There's something Minu always talks about with refugees, but just the idea that it's basically permanent. Like these aren't tents where like they're gonna move. Like they've been there for over a decade, and I don't think they're leaving anytime soon. Like when the patient comes in, you get like a little booklet, and so like they'd come in and like the booklet's a newborn baby because like they get the booklet. I think it's like when they're 2 days old, and then the kid would walk in. He's like to my chest, and he's like he's 12, and I was like, that was really heartbreaking to see. But like they're there permanently, so like trying to find the solution and not have them have to rely on like these medical missions that come every 3 or 4 months if they want to get medical treatment is something that I thought was really important. And so, oops. Oh, wait, no. Okay, so the question was why dermatology specifically? And I think so a little bit of background, like obviously there's a lot of my anecdotes, and I think that the research that I did just supports everything that I saw with my eyes, which is the idea that if you look up any statistic about refugee camps, the #1 medical condition is always going to be skin. And so just to give a little context, like for example, you see the 2.7 to 33%. 2.7 is the prevalence of eczema worldwide. More than 33% is what you see in camps. So that's like 12.5 times greater. And this isn't just because of like the population demographic or the profile, like it's because of the conditions that they live in. So like, for example, if you look at Syrian refugees that are in Germany, it's about 5 to 6%. And so it's significantly greater when you look inside the camp and in Jordan because of like the climate that they're in. And then that's not just for for eczema. So there's that study actually was done in Jordan. So you can see like the profile for like all of the most common diseases. Eczema is the biggest, but like all of these diseases are found at much higher prevalence within the camp when you compare them to what's happening in the world. And I think one thing that we have to keep in mind when we look at like the solutions and what people are doing is this idea that when the Syrian civil war started 2011, the refugee crisis starts around that time, like 2012, 2013, people didn't know that that skin was going to be a really big issue. And so they were completely oblivious. It wasn't until years later that they were like, oh shoot, this is a big problem. And so they already started really late. And so once they find out it's a big problem, they're like, okay, we need a solution. And honestly, I have 2 solutions up here. It's basically one, but we'll get to that. The top is medical mission, so just a picture of them in the camp. That's basically how it happens, especially for specialties. So one thing I learned when I talked to a doctor was that they actually do have a general practitioner, but getting a specialist is like really hard, specifically, and then dermatology is even harder. And so like you have to think about it like these people, they don't get paid when they go on a mission, like it's completely volunteer. So like not only are they paying for obviously like going there, but they're also losing a week of work. And like dermatologists make a lot of money. So it's like giving up a lot to be in the camp and just donating their time. So like medical mission, so like the camps basically only serve dermatologists maybe 4 times a year. And so, and then you have the really high prevalences, that's not enough. So the one solution that I learned about when I was talking to someone in the field was derm relief. And so basically you could think like it's really hard to get a dermatologist to donate their time to fly all the way to camp. So what if we just sent pictures to a dermatologist? So basically what derm relief is like the general practitioner that's in the camp can take a picture, upload it to this app where a dermatologist can volunteer and like look at the image and diagnose, which in theory is easier than having to fly a dermatologist out there or like them fly themselves out. But the problem is you still have the limiting thing of like needing a dermatologist to volunteer, which in itself is really hard. And I think a testament to how hard it is the fact that derm relief is currently down. So it's not really being used. I think it was up for maybe like a year. They went to the camps once and then it's not up. We're trying to get in contact with the founders because I have a mutual connection. So ideally I can talk to them because they do have good data sets and obviously insights because they worked in the field, but it's definitely a solution we want to stay away from. Like my goal was kind of get as far away from needing a doctor or a specialist there as possible because that's always going to be the limiting factor. And that's what kind of pushed us towards AI, which is basically just empowering them by like putting the tool in their hand. You're not going to have to go through a dermatologist. And I guess like when I first came up with this idea, like it's dermatology, it's with refugees. Let me talk to an expert in the field. And so I spoke to Dr. Abrar Qureshi, he's the department chair of dermatology at Brown. He's been on maybe 6 to 8 medical missions over the past like decade. And so he's really involved in the field and he has a lot of insights. He was actually the person, so apparently he advised the people that founded Derm Relief, so he had a lot of insight into the field. And there were two main things that he really told us, which I think were really beneficial. The first, and maybe something we didn't want to hear, was that it's a lot, and I think Manu, even when we talked about it, he's like, oh, it's easy to diagnose with the image, like AI can definitely do this. It's a lot harder than it seems. Like, you might think you can take a picture and like an ML model is going to be able to get it right. We're going to get to why that's not really true. But so that was kind of like not hard to hear, but like it's important to know. But one thing he also did say in that same meeting was like, no one's doing anything, let's do something. And so that was obviously like when you like everyone that we've talked to when it comes to this project, there's Abdul Wahab is also with me, but he's not here today. But everyone is really excited. They're always like, okay, let's do something. But it's just there's a lot of work that has to go into it. And so the problem he was talking about, basically, he showed us a lot of papers. The one we're going to focus on, just for the sake of this presentation and time, is the one in the top left. It's actually published in February of this year. And the third author is actually from Stanford. So I sent her an email. She was great. We met with her on Monday, so we'll talk about that. But the paper really has two really key insights, which is here. If we look in the top left, basically what they did was they tested a model, but what they also did was they tested physicians by showing them images. And so if you see those number, a board certified dermatologist only gets an initial diagnosis correct from an image without symptoms and talking to the patient 27% of the time. If you go to a primary care physician or just a general practitioner, it's 14%, so half of that. So like, so I guess I guess the one positive is like what the thing saw was that deep learning models basically like near what a board certified dermatologist would be, but like, is that equally as good or is that equally as bad? Because they're not even getting it right a third of the time, which isn't ideal. One thing I will say is that we were able to replicate this. So Abdul worked on a algorithm and we got similar to this, like 27%, slightly less because we're using a different data set, but we got access to new data sets, which is good. The one thing that was really cool in this paper, though, was the idea that when you actually pair a physician with the model, they actually perform significantly better. Like even a board certified dermatologist is better by like 30% or 40%. A primary care physician is 69% more accurate than when you pair them with the deep learning system. So that was really impactful because like, okay, maybe right now we're not at a point where like we can just have them take a picture and diagnose it, but maybe we can help the general practitioner who's there, who's only correct about 14% of the time, do a little bit better. And so that's when we reached out to the third author on this paper, Dr. Oksana. So she was really awesome, and we met with her on Monday. And she had a number of insights, which I'm going to go through. So the first thing she talked about was basically focusing on empowering a primary care physician because that's where you can see the most benefit. She talked about, I think Stanford's even doing like, they have some clinical trials that they do where like they're seeing even in hospitals in the US that if you can give a primary care physician a machine learning model, they can do significantly better. And so she kind of thought we could start there because even from a technological perspective, like it's the same model that you're training, it's the same labeling of the images. It just, let's have a little bit less risk and not them diagnosing themselves at home. Let's have a doctor still there to be like overseeing it, which I think is a good start. So it was a good insight. Yeah. And then two really cool things, which the hardest thing we talked about, and we've talked about this ever since we got on this project, was like, where do we find data? Because like, it's hard to find good data sets. Like the images that are free online, one are all white people and two are not the best images in terms of labeling. But there's these two data sets that she helped us gain access to, which is Fitzpatrick 17K, which is like 17,000 images, 17,000 images, and then DDI. DDI is diverse dermatology images. It's actually the data set that they used in the paper that I showed you, which is about 600 to 700, but they're like really clean labeled. They have diverse skin tones, which was actually the purpose of that paper. We've done some. And so we're gonna work with those models. The third thing she talked about is because our goal is to obviously get in the field. And one thing is like when you're in the field, like every picture they take and we gain access to is like you can iteratively train the model and obviously make it better because it's for a specific demographic. But she said that we basically need an IRB and we should work on getting an IRB ASAP. We tried seeing like, is there any way we can get like under someone else's IRB because that might be easier. But she basically like, unless you can find someone that's working with the same population in the same country, it's not gonna happen. So she basically advised us to like hone in, get a specific idea, get all the details hashed out, and then apply for an IRB. So ideally we can work on that. Which brings us to what's next. We want to apply to the grant because that's due very soon. We also are working on creating a new algorithm based on the new data sets that we have access to, the Fitzpatrick and the DDI. So I think Abdul is currently working on that. So hopefully we can get that soon. Want to plan to get in the field. This has a lot of moving parts, whether it's IRB on Stanford side, also getting access to go with the organization. I'm already going with them, so I'll be in the field. Like, so there's gonna be something that I can do, but like can we actually work with patients and use the technology is a different story. So we have to get like some different approvals. There's also like a lot of stuff with the government there. But I'll be in Jordan July 5th to July 12th. Abdul may be coming with me. So it'll be cool to kind of get in the field and see what we can learn and what we can do. And then this is a little separate from the AI dermatology side, but just in general with refugees, if like we've learned of a lot of really cool tools, whether it's FoldScope, SnapDX, Inkblot. So like connecting any of these Frugal tools to refugee communities, I think would be something really cool and that I'd be interested in doing in the near future. And then thank you to the teaching team and everyone.
Questions, comments? Yeah, it's really rare to have that kind of a field insights. So this is phenomenal. Yeah, I think maybe on the population side, IRBs are even more trickier when working with vulnerable populations. And you had also mentioned certain threads around, skin is something that's very private and certain kind of social. I'm wondering whether there is an intermediate ground to prove the technology and test. It's still in the same population, but not refugee. So the climate is the same, some of the abundance is the same. That's where the tool is tested first or validated in a neighboring population. I don't know whether that makes sense for Jordan. Do you see what I mean? Like finding a hospital in Jordan, would that give us the right, or maybe it won't?
It made, so the paper from where I showed the breakdown was actually, so there was about medical mission in Jordan, but like even when I go, like we have, there's like, because the government doesn't like when you just like, they don't like that you're just helping the Syrians, and so they're like, no, you have to do clinics in Jordan as well. So like that paper was, I think majority refugee, but also in the paper they talk about like neighboring just like cities and clinics that they worked at, and then also like in the summer we also just
very specifically for IRB, there are certain sensitivities around that, and it might just be easier to get approvals, and the study site could be right outside first, just so that there is more than academic. For IRBs, it's not just here; it's also in the field, and we could find a study partner who's in the field, not in the camp, but on the board.
Yeah.
Anyway, any other comments? Okay, let's switch. Yeah.
All right, the breast cancer screening, I think they're all online.
Can you guys hear us?
Yeah, I'll just present my screen.
Yeah, you guys are next. No. It's like so much content with such a rush. I wish we had like a day-long retreat to do this and unpack this.
Is my screen visible?
Yeah, we can hear you. We can see the talk. Take it away.
Okay. So, hi, we're working on breast cancer diagnostics specifically for India using ctDNA. So, for our by the numbers, we wanted to first give a sort of global overview of the problem. So for females, breast cancer was the leading cause of cancer incidence in over 157 countries and deaths in most of these countries. So the mortality rates are pretty high. And it's estimated to be around 2 lakh newly diagnosed breast cancer cases and almost 7 lakh breast cancer related cases in 2022. And a third of these patients might have relapses, metastasis, and even may become chemotherapy resistant. So this essentially highlights the importance of looking for promising biomarkers and therapeutic agents and sort of improve early detection and therefore increase the likelihood of the treatment working. So for coming to the Indian context and why there are current problems in the breast cancer screening over here, the most common cancer type in India is breast cancer. So on an average, around 1 in 22 to 26 women have breast cancer and are diagnosed with it. However, Indians have a lower rate of survival as compared to Western countries due to the delayed initiation of treatment, which is likely due to a delayed diagnosis. So a reason why mammography doesn't work is because the breast tissue itself in Indians is a bit more dense, which sort of leads to a lot of false positives. So this may be causing too many false positives, which would further not make it the best screening tool. Additionally, there's the aspect of social stigma. There's a lack of adequate mammography machines and manpower who have the expertise to use these tools and make the correct diagnosis. And there's a skewed distribution of available resources, as in the more tier one cities or the richer places do have more access to these good quality tools and good quality healthcare and manpower, whereas the more rural areas do not. So therefore, it's also important to find an Indian specific biomarker, which is more prevalent in India, so it increases the specificity, or just one in general to make a better screening tool than mammography. So some background information about the tool that we decided to generate is given on the slide, so I'll just go over it very fast. So ctDNA stands for circulating tumor DNA, and it's present in most cancer patients, and it essentially originates from cancer tumor cells. Target ctDNA of a known sequence can be detected in biosamples, which are mainly blood and urine. As part of a liquid biopsy, we are more interested in blood. And the detection of ctDNA can be performed using aptamers. The sequence of the ctDNA has to be known. Aptamers can be generated using certain techniques, which I will be coming to in the following slides. So we picked a target gene, which is the PIK3CA gene, and its studies have shown it to be found in early and late phase breast cancer patients, so easy detection. It has been, the presence of this DNA has been reported in plasma and urine. Again, it works perfectly for our tool. The target sequence for the DNA for this gene has been identified, so we already know enough about it to generate an aptamer. So aptamers are generally generated during a screening process called systematic evolution of ligands by exponential enrichment, SELEX for short. So essentially you have many single-stranded RNAs, you kind of run them through a gel and you screen the ligand receptor binding. In this case, the ligand would be our ctDNA and the receptor would be the aptamer. You generate certain KD values. So a lower KD value indicates that the binding affinity is high. And then you go on and go forth and screen and select a certain target aptamer that will work for the tool. So we have sort of thought about this, and we came up with a range for the calibration curve that we would be using for our tool. So the concentration of total ctDNA in healthy individuals is around 30 nanogram per ml of blood plasma. But in cancer patients, this goes up to 1,000 nanograms per ml. So it also could, the lower range is around 100. So we thought that 100 to 1,000 nanogram per ml should be our calibration curve for this instrument, and the level of detection, what we want, the ideal, the sensitivity should go up to 100 nanogram per ml. So again, it'll be a simple yes or no test, like a pregnancy test or a COVID test, essentially. So here is a sort of simplified design. So it's a simple lateral flow-based assay where a test and control line appear. There's a control zone that changes color always, and there's a test zone that changes color only if the result is positive. You have aptamers in your solution over here. It sort of binds to the specific ctDNA, which would then release the gold nanoparticle, and then a color is generated with certain chemical reactions. This cost is very, very low compared to what an average nanogram would be, which I think is around $250, more or less. This would be $5 max. Yeah, so this is non-invasive. It has no aspect of social stigma. It's easily accessible. It's cheaper and it's easily affordable. It could if it's developed well enough and there are Indian specific biomarkers available, we couldn't find any, we've only found this gene, then it could essentially build up to be more accurate than mammograms as well. It could be used in place of a mammogram to say yes or no, you might have breast cancer or any other cancer. But after this, a confirmation should be done using imaging. So it's in no way a replacement for actual imaging. So just wanted to put that out there. And we've also identified potential drawbacks of this. So blood plasma has to be separated first to be loaded onto the tool beforehand. So this can be done using a paperfuge. But again, if this tool is implemented in hospitals itself, where people have to go get the test done rather than doing it at home, it can be done in a hospital lab itself, where they have centrifuges for blood tests. So it can be done in a relatively low-cost manner. However, there might be background noise and interference from other double-stranded DNA that is found in plasma, and it's always there. We haven't sort of found a way or come up with a solution to remove that background noise. And since ctDNA is in the concentration of the nanogram range, amplification might be necessary. However, we found a low-cost method to do this. It's in a thermos, so it can be done in any environment. It doesn't need like specific temperature requirements and everything. Yeah. Future directions, we basically want to identify an aptamer, maybe. We found a company that does that. And we want to try looking for more specific biomarkers for the Indian population. This could be done by maybe looking at databases that already exist. And we would also ideally like to, way into the future, extrapolate similar systems for other cancer types. Thank you so much, and thank you to the teaching team as well.
Hello. So I have a few questions that I actually put on the chat, but I can ask directly. So this aptamer thing works with RNA, right?
It's the ctDNA. So that's the double-stranded DNA that is removed from tumor cells.
So if it is DNA, then are you looking at specific variants of this gene or just any copy of this gene?
Since it would be any copy of this gene that is there, it's found specifically in tumor cells, in breast cancer tumor cells, which is why we picked it. And it's detectable in the early as well as the late phase. So we picked this specific one. But yeah, there will definitely be issues with false positives. And as I mentioned, it could bind to essentially like other double-stranded DNA as well. If it's
No, so because
it's like two puzzle pieces. Yeah, sorry.
So the issue is that I think what you're referring to is RNA. Like when you go and look at expression, you'll see PI3 kinase being expressed a lot. But if it comes to DNA, there's only one copy per cell. So I don't know if this would work per se. And then I think people like Grail, not that this is a big problem, but they're working on this for a long time. And I don't think they've had any simple way to look at ctDNA, and they're using very sophisticated tests and charge a lot of money. They've had trouble to be able to say something about this. They use methylation, for example. Even then, they're having trouble. So I don't know. I know this field a little bit. That's why I'm talking about it. I just feel like it's maybe too difficult a problem to make it into like this kind of simple frugal test. That's my worry.
Dia, can you share a little bit in terms of the markers that people have looked at?
Yeah.
Nobody's actually done anything on ctDNA for these specific markers as yet, right?
No, so ctDNA is being used quite a bit. Like, I mean, that's the whole Grail, and there's a ton of companies.
No, I meant just very specifically for these breast cancer markers.
Yeah, so, but when you say PI3 kinase is a marker, that means that it's being expressed a lot, or a variant is being expressed. So either you look for the variant, or you look for expression itself. So DNA circulating is going to be just one copy per cell. I don't see how it would distinguish like a breast cancer from even my blood, which may not have breast cancer genes.
So there was this one paper that found that the levels of the ctDNA in breast cancer specifically were very high.
Yeah. So that's a
So
overall DNA.
yeah.
Yes. Yeah. That's different from, so just because many cells are being shed and they're dying. So what happens is often people look for these, like if you're treating, then you're killing the cells and a lot of the DNA gets spread into the blood. So you can look at the level of ctDNA totally, but there won't be any differential between PI3 kinase versus BRCA1 or P53. It's just going to be all DNA being spread out. So I'm just saying that this PI3 kinase DNA would not distinguish. And if you're just looking at numbers, why pick PI3 kinase? You can just look at DNA total, right? You can just look at the number of DNA molecules.
No, actually, selects can be optimized to particularly detect a particular DNA sequence. I mean, so there are companies who can do the sequence and finally generate the aptamer, which is specific to particular sequence of DNA. That is doable.
Yes, but if you're looking for variants, I agree with you. But if you're just doing DNA detection, I can do simple gel-based assays, very cheap, and you can detect DNA of particular genes or particular sequences. So I'm just saying there's a little bit of a technological gap here that has to be bridged.
Yeah. Ravi, let's do this. Let's do
sorry.
a catch up on the
Yeah.
same. I just want to
Yeah.
make sure everybody gets to finish.
Sorry. Yeah, I didn't mean
yeah.
to. I didn't mean to monopolize. Sorry.
No. I think it's very important because the whole point of this is that this is sort of the initial steps to make sure that we do figure. I mean, I think there is a general value in thinking about floating DNA. So I think overall, even if the current set of a framework is hard, it would actually be really valuable to have that discussion. So we should definitely just post on Discord a little bit of a time.
Yeah. And I have some
discussion on
ideas on mitochondrial DNA. I can show you some data. Yeah, it'll be fun. Yeah, let's do that. Yeah.
Let's do that as a follow-up. Okay, so I think I'm gonna pass to the Conzo team. Yuki and team, are you guys there? Yeah, Mrinal, take it away.
Yeah, sure.
Oh, I think somebody's mic is on. Okay, you're good now. Yuki, do you want to share? Who's sharing the slide deck?
Dave will be sharing the screen.
Got it.
Once he's, yep.
Yes. Oh, hi there.
Okay, Dave.
Can
yeah,
people see the screen? Yeah.
We can see the screen.
Perfect. All right. I think Mrinal is going to lead us off here.
Yeah, sure. Yeah, so we're talking about Conzo. As we had a brief discussion earlier, it's related to cassava and the toxicity of the cyanogenic glycosides inside cassava. And Conzo is a sudden onset symmetric, non-progressive, reversible spastic paraparesis or quadriparesis due to selective upper motor neuron damage, and it's permanent. Once the kids from Democratic Republic of Congo, Nigeria, all these places get Conzo, and it's permanent. The damage is permanent, and usually they occur in outbreaks, and it's usually linked to droughts, and it's especially common in DRC in Congo. And usually it's related to a monotonous cassava diet. People usually consume mostly cassava, which is high in carb and less in nutrients. And the consumption of cassava is mostly done through improper processing techniques. And the reason is usually it's said to be due to these mainly due to cyanogenic glycosides like linamarin and otaphyllin. And linamarin is most of the 95% of the cyanogenic glycosides are linamarin, and that's what causes the damage. Yeah. So what we did for the project is that we try to divide the whole picture into different aspects and try to see where we could make an intervention and make a change. So it could be at the level of the cassava plant, and it could be at the level of the processing of the cassava. It could be at the level of the environment, the level of the host or the treatment, and after that, any interventions like behavioral changes stuff. But in our case, what we focused mostly on was processing the cassava, because that's the place that can have the highest impact on how these people live.
Oh, thanks, Mrinal. So just to go over, as Mrinal mentioned, this is endemic, particularly in DR Congo, And there are different methods to process cassava. It's widely eaten around the world, but the primary method that's used in the affected areas is harvesting the tubers, soaking in water for 3 to 5 days, drying, pounding into flour, and then eating in a porridge, often called fufu. And so how we approach this, and I'll just want to say from the outset, really impressive to see all of the work that the other groups have done. What we were proposing here is a series of experiments. We haven't actually gotten to complete any of them, but nevertheless, we wanted to present this to you and get some feedback. So our hypothesis is that the pH of the cassava soaking water is impairing the potential detoxification that can be happening during that process, and therefore that this is negatively impacting cassava Kanzo incidence and could potentially be improved with frugal materials to alter this pH. So a bit of the chemistry here, linamarin is the cyanogenic glycoside. Linamarin, while being soaked, is processed by an enzyme called linamarase. This produces acetocyanohydrin and ultimately cyanide, which is then eliminated during this soaking or processing process because it's a volatile compound. So in this case, linamarase is your friend because it's helping take this cyanogenic glycoside and produce cyanide that is then released. So the problem is that soaking ends up acidifying the water that the cassava is being soaked in, and low pH inhibits the action of this enzyme. And we think that water scarcity exacerbates this problem of acidification because when there's less water available, there's more likelihood that that water will be reused over and over again, and these acidic compounds will build up and therefore prevent the effective detoxification. Sorry, I forget if this is my slide here. I think it still is. Yeah. So what we're proposing is a series of experiments to evaluate this process and see if we can produce a meaningful intervention, a meaningful low-cost intervention in this process. So the first experiment that we're planning is to emulate the cassava soaking and detoxification process. So obtaining tubers, dividing them into pieces, soaking 1/2 for 5 days, using low-cost test strips to monitor cyanide levels both in the soaking water, and then comparing cyanide that is retained in soaked cassava versus unsoaked cassava that is our input material, to evaluate the proportion of cyanide that is eliminated throughout the soaking process and use this as a foundation for further experiments. So I'll hand that off to the next speaker.
Yeah. So in the same line of sort of processing cassava, so to the point that where it is more digestible, one of the way that we want to address in making it more effective in detoxifying is how can we actually adjust the pH that the cassava is soaking in. So as Dave has shown earlier in the cassava processing process, cassava is typically soaked from 3 to 5 days. And exactly this is what we're trying to emulate here. So we have chosen 4 different neutralizing agent and with the water as control. So we will add soak the water as well as various neutralized reagent at the same time with pieces of cassava. And with each of the days, we'll measure both the pH as well as the cyanic level. And so this is what we will expect to collect as data for figure 1 and B to see the cyanic level over time as well as the pH over time. But at the same time, what we care about is also the cost effectiveness of these neutralized reagents, particularly at the site. And Dave, if you can move to the next slide. And then we realized actually the experimental setup that we're creating here is wonderful in addressing the pH level. However, the quantity of cassava and the toxicity level of the cassava might not, in the experimental setting in the beautiful lab of Palo Alto or Arizona, might not be comparable to that of Congo. We actually have a scientist, Matt, who will be traveling to the DR Congo to the affected region. So what we plan to do some experiments there will be to test the pH level of those cassava soaking pits in both affected region and unaffected region to get a sense of where the pH actually lies in the real sites. And we wanted to test one of the more effective reagent of neutralizing from experiment 2 and see how well we can deploy those reagents in neutralizing reagent, neutralized pH in the pit, and as well as like how costly it might be. So, and maybe at the same time, we want to research local availability of some more frugal and more reasonable neutralizing reagent in the affected region.
So the second hypothesis that we have is that cyanide content in cassava can be eliminated or decreased to tolerable levels by alternate methods of processing. So linamorase being an enzyme is inactivated by heat, and boiling is also expected to reduce the cyanogenic glucoside content in cassava. So we hope to include different steps in the processing and try to assay or measure the levels of cyanide in various methods of processing. So the experiment 4 that we are planning to do is to emulate different methods of cassava processing. We'll essentially peel the raw cassava tubers and process using each of the below mentioned methods. We'll dry and pound the cassava in one method. In the other one, we'll include a soaking step, and we'll measure the cyanide content at days 1, 3, and 5, and we'll follow it with drying and pounding. The third method that we are trying to do is to include a step of boiling for 20 minutes, which will be followed by drying and pounding. So the powder that is obtained after pounding through various methods of processing, we'll essentially mix them with room temperature water and make a paste out of it and test the amount of cyanide that is present using reagent strips. So we haven't essentially gotten the strips in our hand. That's why we haven't been able to conduct the methods per se. So we hope to get the reagent strips next week and hopefully share the results with the team by next week.
All right, so there are some long-term directions which we want to work upon. For example, we need to still work upon the whole detailed process of improving the detoxification soaking techniques. Also, we want to increase the accessibility of low-cost pH neutralizing agents, as well as we want to test how feasible is the incorporation of the process of boiling in the whole processing technique. And last but not the least, it is a soft measure of social mobilization for education on improved soaking technique, and as well as finding other alternative processes and methods. That's it. Thank you, Manu. Thank you, teaching team, and everybody who worked with us. Yes.
Quick round of questions. So just a quick question, Dave, Divyanshi, everybody. Do we know for sure that, the diffusion of the water getting in, I know you guys had mentioned between 3 to 5 days, water is scarce, so sometimes people don't soak it long enough. Do you guys know absolutely that water does diffuse all the way to the core of the cassava? So Dave, when you've been in the field, have you ever taken one of the tubers and cut it in half and confirm what if a certain portion of the tuber is never receiving?
Right.
Yeah. What is the diffusion time scale for this object? Because we could very easily test that.
Yeah, absolutely. No, I think that's a good question, and I don't know the answer to that. Yeah, it's an enzymatic process that's happening, but a lot of the enzyme is in the peel, and it might be that enzyme is only reaching the exterior. It might be that smaller pieces would be more effective. As we saw in some of the videos on this, making smaller pieces might not be super effective in the pits and being able to pull them out again, but that's a good question about whether it's even reaching the center.
So you're saying the enzyme is in the peel, so it wouldn't make sense to peel it before soaking. But then on the other hand, there is a spatial distribution for that enzyme.
Yeah, I believe they do peel. I think the enzyme is both in the peel and the tuber, but I believe it's higher concentration in the peel.
I see. So by peeling effectively, you are suppressing that process too. But
perhaps I don't know. Yeah.
Because if you don't peel, you don't get effective diffusion in.
Right, exactly.
If you peel, you lose the enzyme.
Right.
Yeah, I don't know whether there is kind of an intermediate ground, which is like potatoes. Sometimes I like poking holes in a potato, like best of both worlds.
Yeah,
Manu, can I add something?
Yeah, go ahead, Mrinal.
Yeah, so the linamrin is actually inside some vacuoles that are the vacuoles inside the cell, the tuber cells, and the linamrase enzyme is in the cell wall of the cell wall.
So when you crush it or when you grind it up, the cell wall, the condenses get broken down and they mix together. That's what happens when they grind it down. But when they try to put it in the fermenting pits, they actually put it in larger pieces and they don't ferment it often. Like they don't ferment it enough for 3 to 5 days, and they have a lack of water. So essentially, cutting the cassava into smaller pieces would definitely help. Yeah.
I see. Yeah. Any other questions? Henry was supposed to cook us some fufu, but he bailed on us, looks like, right? Or
Well, we tried. It didn't go so well.
oh, that's okay. We still wanted to see. Okay, he did attempt it. Oh, you attempted. Okay. Okay.
I think you have 5 pounds of flour, so you can always try again.
Okay. I think we're gonna succeed in that. Okay, we have the last team, the antibiotics team, the chicken antibiotics. This was fantastic.
Thank you, guys.
Thank you, everyone.
Last but not the least, Avinash and team.
Shall we begin?
Yeah,
Yeah.
you can share your screen. So Avinash, your screen was visible a second ago, and it's
Yeah.
oh, perfect. It's there now.
So our project is about making an antibiotic detection kit. So as we know, antimicrobial resistance or antibiotic resistance has problems like treatment failure, rising cost of taking medicinal help, and it has economic impact, and also there is a risk on the food chain. So we thought of inquiring that what are the antibiotics present in chicken. So for that, we interviewed a poultry farmer, and with these set of questions, and so in interaction he mentions the antibiotic he uses in the poultry farm, and also we inquired about that what he do with the fecal dispose. So he says that it goes to the field, and after and he also claims that once this kind of manure goes to the field doesn't require any more fertilizer. So because that is so powerful. So so while mentioning, he mentions one antibiotic, a lot of antibiotics like Biotrem, Lixin, Asterim, and Tetracycline. But we further inquired. So on YouTube, there is a community which is growing, and these poultry farmers are sharing their practices, how they can take on to the disease which is spreading in chicken. And there is a lot they are sharing these short reels and videos. With videos have considerable views also. So they are saying that how they can use this tetracycline for in their poultry farm. So basically, if we look at the chicken cycle, it looks somewhat like this: that antibiotics are given to chicken, fecal dispose again goes back to the agricultural field, and through crops, it is again consumed by humans, and chicken meat is again consumed by human. So some way or the other, antibiotic is getting back to the environment or getting back to us. Also, further inquiring, we looked at this paper where we saw that it is paper from it is a little old paper from 2010, but it says that tetracycline is something which is found in the chicken meat across different countries. And also a study was conducted in India which maps the hazardous quotient also. So for various antibiotics, so like enrofloxacin, ciprofloxacin, and again tetracycline is one among the hazardous ones, and it was found in the chicken in various agroclimatic zones of Chhattisgarh. So we thought of going ahead with tetracycline, that we can make some kit which can detect it. So for that, we looked at some available tests which are there in the market. So so tests are in the range of least is $320 to $1,000. Uh, so the cost of test is more, whereas the cost of chicken is 250 to 300 rupees per kg. So it is something which don't match here. So this table is to show that we need something which is cheaper and which can be used for detection. So it will have, if we do this, it will have an educational aspect to it, which can go like, one, we can work with the society, and one, we can work with the farmer. These images are representative images. So in society, we think of working with school, where school can become and school can amplify the awareness around antibiotics. So we can work with teachers, where teachers themselves do some inquiry based activities with the student and do inquire about antibiotics and detect it. It is not mere passing of information. And with children also, we can incorporate certain inquiry based activities which children do inquire and do detect these antibiotics. Also, is while schools do this, schools and the community around uh, can complement, schools can complement the community around in raising the awareness. And also the kit should be as cheap as, so that if we are working with the farmers, then there can be awareness and training for the butchers who can use the kit and who can perform that test. So also there can be a community of practice for farmer, which who share among themselves that the practices for antibiotic free poultry farming. So this, the next is a flow diagram. Rida will walk us through that, how we can go ahead with the detection part.
Rida, can you hear us?
Rida, we cannot hear you. You are on mute.
Oh,
Oh,
okay.
perfect.
So when we were going through the articles, we found that there is a gap between what the technology should be. There is a very less frugal technology available. So we got inspired by one of the articles that has printed aptamer based test assay for lateral flow for another antibiotic. So we got inspired by that. This diagram represents that for tetracycline here. We can go to next slide. So we have done a feedback for this. So this is the snapshot of that. So we wanted to know what are the sensitivity and limit of detection and accuracy. So in the previous table, when we were accessing that, so we saw that the cost is way too higher for this. So for bringing down the cost, we need a assay which we can use for educational purposes as well as for regular customers or companies. So people will be more aware of antibiotic resistance in general. That's it. Thank you.
So Rida, would you like to go into this trademark table and give a detailed walkthrough?
No.
Okay. Okay. So
Yeah, do you want to unshare your screen?
yeah.
So questions for Avinash and Rida.
So yeah, so we wanted to share that we till now we have just identified the gaps, that there is a gap existing for designing such a kit. And yes, and we have done some inquiry in terms of what we can detect and the education, what can be an educational aspect uh, for such an intervention.
Yeah.
Yeah.
So, quick sets of questions. So, Avinash, one thing I wanted to ask is, currently, what is the policy? Basically, any farmer can get tetracycline from any pharmacy and can treat their chicken. And because this is the chicken go to the butchers, there's basically no regulatory framework for treating your animals currently.
Yes, it is a very over-the-counter available antibiotic and it is accessible to anyone who requires it. So, actually, in the veterinary medicine in India, we do not generally require a prescription for that. So, it is like used like, just like that.
Yeah.
Currently, the cost of tetracycline is very low,
Yeah,
I'm assuming. There is no
it is
cost
low.
barrier for anybody to use as much
Yes, it
tetracycline as
is
possible.
very low and the dosage as well is very low. So, it is like used rampantly.
I see. Yeah. Yeah, that does sound scary. Any other questions? Uh, yeah, I guess maybe one of the threads to do, Avinash, is we'll kind of do a quick follow-up. It is on the educational side of the story. Anupma in the full scope community has been running a lot of antibiotic awareness workshops. And we should look through her material itself, but then really build and choose a specific site to run a small workshop. I don't know if you have a workshop plan in the near future itself, because I know you just came back from Chhattisgarh. So it would be valuable
Yeah.
to plan a very specific antibiotics awareness full scope workshop.
Yeah, so the images I added was just representative image. That's how we work with teachers and students. So yes, I do work with teachers and conduct teacher training workshops. So yes, we can work with teachers, and if
Yeah, I
we
think that's a
have,
very,
if,
very immediate next step that I would see to actually
yeah,
implement.
yeah,
And then actually, just before we end, that was the last talk. Before we end, we have a student from last year, and she was going to show something she's been working on, biodegradable materials. So do you want to just spend maybe 5 minutes or so? And I know you also have materials, so you can. Yeah, forget the slides. Just show what you've been working on. This is also the power. I just wanted all of you to realize that when you take on something, you kind of pursue and play with it. And it was kind of it was a fun way of reconnecting back. And you'll be in this place. It takes many years to get to where you want to get to. You should just do a quick intro for yourself too.
Hi, my name is Nafet, and I have teammates Adil and Them also worked on this with me. This is actually funny because we ended up working on this biomaterials. We thought it had come, I'd seen my roommate work on some materials. I took soft robotics with Renee Zhao, and it was very interesting. And it was only yesterday that she told me, my roommate told me that she was inspired to do this because she saw you talk in Egypt about
Yeah.
and it was kind of all coming back into a circle.
Egypt was a long time ago.
Yeah. So we wanted to work on biomaterials because specifically in bioplastics, because we know the plastics stick around for thousands of years, and what are ways that we can create the waterproof and durability properties of plastics, but using biodegradable and easy to find materials. We made all of the applications. They're just samples, but these ones are made from gelatin and glycerin. You can play around with them. These ones were from this week. Yeah. These ones are from this week. It's been hanging out. This is the first one that we made. So this is with starch, when you add starch to it. This was the very first experiment. We just dumped it in a little bit of Tupperware. And you can see it's very strong, and it's lasted for, this is, week 1 was when we made this one. And so it's been hanging out in our apartment and it's been working well. This is,
Thinking of biodegradable oxygen bags.
yeah, we made them in different shapes to experiment with, what can we do with them? I think the main thing with this, yeah. When I think of Manu, I think of just play and having fun with science. And I'm sure, throughout this quarter, I'm sure you've been wowed by how he could jump from one area of engineering to another, to another, to another, and he's so knowledgeable. And he comes at it with a very, with curiosity. And that's what we wanted to bring into this, was just that sense of play and what can we do when we just throw a bunch of things out there and put them together. And so this is one that we reinforced with fabric and with using 50% less potato starch. We use potato starch for a lot of our materials, but we found that there's like a give and take of, the more potato starch you use, the stiffer it becomes, but it also gives you a lot of structure. The gelatin also gives you this supple, very plastic, very flexible, elastic properties. And so how can you have the best of both worlds? So we reinforced with fabric to help it with that. This is not the best fabric to use because it is plastic, but it
There are
also
many other
works with
fabrics
cheap
out
cloth.
there. So,
Yeah, and the idea for this is that you'll be able to sew it together. And then what we used is some of the ones that you saw, these are made from materials that we formed, remelted, and then formed again. And so this is also you're able to do this. What that means though is that it's not very heat stable. So you have to be careful, but it is completely 100% waterproof. And so with that, we thought, okay, if it is waterproof, then what are some applications for it? And so we made these 2 samples. They're not pretty, but they're not pretty. But you can use remelted material as glue and make little pouches. And these are completely waterproof. As long as you don't put hot water in them, they are pretty stable. So that one is with starch, and this is without starch.
And then, from a biocompatibility point of view,
Yeah.
There's basically nothing that leaches out of it.
No.
So it's all mostly stuff.
Yeah. Starch and gelatin. And I think this one is agar-agar, which is algae.
I think with fufu, the sour, we should also just do a materials workshop. It'll actually be fun.
Yeah, about it can handle a lot of I don't remember off the top of my head. My partner wrote them all down, but I can share afterwards.
Yeah, I think maybe one thing is talk a little bit about one packing layer.
One other thing that we wanted to try was also, we had a lot of dog bone specimens, but Renee Zhao said that her Amsterdam was not for us to use. But we wanted to do some tensile testing. So I think we will eventually look
pretty
for.
straightforward. Yeah.
Yeah.
There's tons of instructions for that.
Yeah.
Okay, let's end with a little bit of that summary. So first of all, and I think recipes for materials to try would actually be really fun. Yeah, I think a couple of comments that I just want to make in the end before we go out for donuts. So the folks that are online, you don't get to eat the donuts because they're only here. But I just want to say, wow, I mean, this was fabulous. Just incredible to see the amount of creativity. And even for a very short period of time, I know many of us, in this same time to be able to identify the problems, many of you went out in the field itself, I mean, my mind is blown and just so much potential. But, you know, I want you to also just remember something, that in the end, all of that potential sits there unless some of you take that on and say, no, 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 I want to move to the next stage. I really do want to make sure that what you have done or have you been trying to do actually reaches people in some way and form. So this is just a little bit of that encouragement. You know, of course, the whole purpose of this class is to create a community of people that have empathy for these problems. Many of you have become friends along the way, and this is really how you build teams. You don't go alone at it. We've seen this over and over in the years. And, you know, my real desire is that many, if not all the projects actually end up reaching people that you care about. Uh, there's a couple of threads on the immediate to do is 18th. Is that correct? 18th, right? 18th is the deadline for the Frugal Science funding. So the template is pretty straightforward. Go online, create sets, take a look at the template itself. I would love to just have every team submit something. You know, even if it's a small amount of funds, it'll open up travel, it'll open up ways that many of you could meet each other in the teams. And again, it kind of gets you started in being able to also build resources around projects and ideas. And the Discord always remains open. I'm going to structure some of the discussions around lab notebooks. There is a lot of immediate work that you've all identified. And, you know, although the class is over, none of the things in terms of we haven't actually achieved the target goals of what we are trying to do. And, you know, during that time, lots of projects will still pivot, change, modify. That's perfectly okay. If you care about this, then make sure, and then do write to me if you are submitting one of the grants. And then I'll do one-on-one meetings just with every team to just make sure that we have clarity on next steps. And then I just also want to say thanks to Hope and Rusha. It's not an easy class to run and teach. It goes in many different directions, and you guys have been troopers. There is a lot of things, and I love the fact that many of you are online at 1 or 2 a.m. your time, and you're still wide awake into it. It just brings me so much joy. So to be continued, there is donuts and coffee outside. There are reviews for the class that everybody should fill out. Without those, we can't fund the class and the kinds of resources that sometimes are needed. And effectively, I'll catch all of you online one-on-one. I'll just send a message, and I think we'll follow up on what comes as next steps. Folks who are in here who have time, hang out for a little bit so we can have conversations and talk a little bit about next steps. We're going to say bye, so some of you could actually get some sleep. And I'm hoping we will see each other online pretty soon. Bye, everyone.
Bye.
Okay, let's get some donuts.